Hello, everyone. Good morning. Welcome to day 2 of CogX. You are joining us here on the cutting edge stage, which, as I'm sure the title makes pretty clear, is all about what really is at the cutting edge of science and technology right now, and what's going to be coming next, or possibly even a little bit further along, a couple of years into the future. My name is Gemma Milne. I'm a writer, author, podcaster, and I focus specifically on science and technology, predominantly deep tech. So things like biotechnology, battery technology, quantum computing, anything that's kind of coming out of the science lab and into the real world, those sort of early stages of brand new cutting edge technology. So I'm really excited to be hosting the stage. But the other side of me is I recently wrote a book called Smoke and Mirrors, which is all around hype in science and technology. So whilst I love to learn about and cover all these amazing new things that are coming into the world, I also think a lot about how we talk about them and shall we say, the reality behind the narratives that are said around technologies. And in the book, of course, there's an entire chapter on AI, one of possibly the most hyped up technologies, both for good and for bad. So that's me. I'm going to be on the stage all day. But the first session, I'm absolutely delighted to be moderating. So this session, as I'm sure you guys all saw from the title, is really exciting. The next Nobel Prize for Literature is Alexa. So as you can imagine, we're going to be talking about creativity and AI. And joining me on the stage is the author of this wonderful book, The Creativity Code, Marcus du Sautoy. He is the Simone Professor for the Public Understanding of Science and Professor of Mathematics. Marcus, please join me on the stage, and thank you so much for coming and chatting to us at CogX today.
Great to be with CogX again this year, if only virtually.
I know it's an interesting experiment, shall we say, in seeing if we can gather. I mean, there's so many different sessions happening at CogX, so many different people, and I'm excited to see how they manage it with all these various different stages. But it looks like it's going brilliantly so far. So we are going to be talking about AI and creativity, or more specifically, can AI be creative, or what does creativity mean when we're talking about artificial intelligence? But before we get into the discussion, I understand you've brought with you 2 poems to show us. One, my understanding, is written by a person, one by an AI. Maybe you can introduce the little challenge. We're going to have a poll about this.
Exactly, it's a sort of AI Turing test to see whether you can see which poem it has been created by a piece of AI. So I'm going to read 2 poems. You get to vote on which one, poem 1 or poem 2, do you think was created by a piece of artificial intelligence. So here's the first poem.
Just before you go, Marcus, just to confirm for people, this is on Slido. So make sure you can go on to the Slido, and the poll will be there for you to vote. Right, Marcus, after you.
Yeah, exactly. If the tech goes wrong, you can put up your hands, but we won't be able to see you. Okay, so a poet friend of mine said you have to have a poetry voice to read poetry. So I shall try and put on my poetry voice for you. So poem 1. Mortal my mate, bearing my rock a heart, warm beat with cold beat company. Shall I earlier, or you fail at our force and lie the ruins of rifled, once a world of art? That's poem 1. So is that by a piece of artificial intelligence, or is poem 2 by a piece of artificial intelligence? So here's poem 2 for you. Imagine now the dark smoke, awakened to fly all these years to another day. Notions of tangled trees, the other side of water. I see it is already here. Sequences of her face. See it is shared. And old friends pass their dreams.
Okay.
So there you go. Which one is by a computer? And has no internal emotional world.
I love it. Okay, I hope everyone is doing their votes right now. I'm going to add my vote to poem 2. I think poem 2 was the AI.
So you're biasing people. You shouldn't do that.
No, I'm adding my vote, Marcus.
Okay.
I like my say as well as a human in this artificial intelligence driven world that we now live in, clearly. So please make sure you do your vote, people, and I'm going to get up on the chat here from the the backstage crew that are managing the Slido. But while we're waiting on those votes, Marcus, I would love for you to tell everyone a little bit more about the creativity code, specifically, why did you want to write this, and what is the sort of question that you were trying to answer in the book?
Well, I think, as you say, there's been so much hype about artificial intelligence and the threat that it poses to us as humanity, about our jobs. So many jobs under threat. It's been called the third industrial revolution. It will have the same impact of wiping out sort of jobs. But I think there was always one thing that we thought would not be a job that could be taken by artificial intelligence, which is our own creativity. And, I'm a mathematician, and I talk about creativity a lot as being very important to me as a mathematician. So I've actually always used this word as a kind of protective shield against the idea that an AI could do my job, prove mathematical theorems. But then I saw something happen a few years ago. This very famous game played between AlphaGo and Lee Sedol, the ancient Chinese game of Go. We've got quite used to computers playing games and beating humans, but there was something that was really extraordinary happened during one of these games where a move was made, move 37 in game 2. It's now become a very famous move, which many regarded as, a real signal that this piece of code was being creative, because it's important to define creativity, because it's one of these rather mystical, a bit like consciousness, mystical words that's quite hard to pin down. So I actually rather like a definition that Margaret Bowden, cognitive scientist, who's been thinking for some time about what computers, or tin cans as she calls them, what they might be able to do. And she has, it's quite a simple definition in a way, but quite user-friendly. A creative act is one that is new, surprising, and has value. And the thing about this move in the game of Go is it was a very new type of move. It was very surprising, because I remember all the commentators when I was watching this live, they all gasped and thought it was a dreadful move, because it was a move you never make this early on in the game, sort of quite deep into the board. But it ultimately had value. Games are very nice places to judge value, because you can see either a move wins or loses you the game. This move ultimately was the one that meant that AlphaGo won the game towards the end of the game. So I really saw this as a kind of a key new moment in artificial intelligence, where something happened in that code which was new, surprising, and had value. And the most important thing for me was that you see, there's been a real phase change in the way that code is being written. Code in the past is very top down. A human told a machine what to do. So if a machine was creative, it was really the human coder who originally wrote the code that you would call being the creative one. But now with this idea of machine learning, where code can mutate, change, reparameterize itself, become something new, it starts to put a distance between the code and the coder. And so what's really intriguing is that this line of code, which said, play on the 5th throw in from the edge, a move that no Go player would make it this early on in the game, grew out of the learning of the code. And if any human had seen that line of code, they would have deleted it, saying, no, that is a weak move. So this is really came out of the learning of the code. It was a creative act by the learning process of the code itself, and was a surprise to even the people who wrote the original code, which was the one that started to learn. So this for me was very exciting, and I thought, okay, a game is very clean, tight environment. What about creativity on a kind of more broader level, our own human creativity? Could it write a wonderful novel? Could it compose a symphony, paint a wonderful masterpiece, or even create a piece of mathematics that we would all find exciting? And so that kind of set me off on this journey of the book. And I suppose it is, it starts with that game of Go, but the journey is looking at how powerful this has been as a tool in the creative arts, written word, the painting and music and mathematics.
Oh well, yeah, and mathematics, which I'm definitely going to get onto to later on, and we'll get a little bit deeper into that. But before we move on to that, so I guess the big question is, well, can it do it, right? And so we're going to reveal first the results of the poll to see if people believe whether or not it can do it based on whether or not they think the poem was indeed by a person or a machine. So the results are for poem 1, 59%. So most people think that poem 1 was written by AI. 41% for poem 2 thinks it was written by an AI. So it's pretty close actually.
Yes.
But poem 1 seems to be beating out.
A bit clearer than Brexit, but not
exactly.
much.
Not much. So Marcus, why don't you reveal to us, was it poem 1 that was written by the AI, which would agree with the vast majority of the audience, or is it poem 2, which is what I thought, and 41% of the audience?
Well, I'm afraid poor old Gerald Manley Hopkins is going to be turning in his grave that 59% thought that his poem 1, was written by a piece of AI. So, Gemma, you were right. It was poem 2. I mean, I chose Gerald Manley Hopkins partly because I've never understood any poem that he's ever written. I mean, he seems to have been on smoking something when he writes most of his poetry. But I think poetry is an interesting place to kind of start with creativity with the written word, because I think first of all it sort of illustrates that poetry is quite gnomic. It leaves a lot of room for your own creativity as a reader, and I think that's interesting. It is a dialogue very often between an artist and viewer, listener, reader, and there's a lot of space for allowing you to imagine things. The second poem, which was by artificial intelligence, is actually Ray Kurzweil's Cybernetic Poet produced it. So this he got the AI to learn on a lot of Victorian poetry, and then kind of synthesized it got the AI to sort of see style and start to produce things. So it's probably that second poem. There's probably kind of hints of poems you might have recognized, which is probably what maybe drew people to thinking that one was human. But interesting, the very first kind of creative acts by an AI were short form written word. In fact, Turing, after the Second World War, he went up to Manchester to realize his ideas of a machine that could do many different things, a universal computer. It was the Manchester Universal Computer. And the team were rather perplexed when they started to find these kind of love letters being left around the lab, signed by MUC, the Manchester Universal Computer. And after a while, people realized, hey, there seems to be some sort of template here. And one of the team had been using a random number generator that Turing had written for the computer that was just picking words of love and filling this template. But it's interesting, one of the first uses of a computer to write things was kind of short form love poems.
Well, this was going to be my next question is, what does it mean to try and ask a computer to write a poem or write music or whatever? And you mentioned here this idea of kind of structures, and one of the chapters that I found really fascinating in your book is the one all about writing music, and how in some sense, possibly in a negative way for musicians, you're able to showcase this in a little bit of a reduction of writing music into patterns of different kinds of types of music and also approaches. Like, for instance, the jazz theory book, the bit you quoted, it says a great jazz solo consists of 1% magic and 99% stuff that is explainable, analyzable, categorizable, and doable. So in my mind, I'm reading that thinking, well, surely then if it's categorizable and teachable, then surely that's actually very easy for a computer to do, maybe more so than a human. So, is that kind of how you're approaching this idea of creativity, that if you can boil everything down into rules that then can be taught to a computer, therefore maybe possibly it would be a quite easy task?
Yes, I think that was the thought, that there is a lot of structure, and of course, but artificial intelligence is code. Code is basically mathematics. Mathematics is the study of structure. So that's why it might be a very powerful way to sort of pick up things that we as humans don't necessarily understand. Often we are creating things and we don't realize the kind of underlying structure that's there. So I think this is one of the exciting things, actually, that we can use this AI as a tool to understand perhaps things that we're currently unaware of. I mean, for example, I talk about Jackson Pollock's work, that, what makes a Jackson Pollock so special and unique? I mean, surely anyone could just flick paint around, but a mathematical analysis of a Jackson Pollock reveals that the kind of shapes that he's making are very fractal in quality, and he had a very special technique. And I don't think he was aware that he was making kind of fractal grip paintings. The shapes somehow have this wonderful property that as you zoom in on them, they kind of never simplify. So it's very scaleless kind of geometry. And that's somehow the magic of those paintings. But I think, it's an analysis through mathematics, which kind of revealed what was special about that. And so sometimes, people will think, well, why on earth would you want an AI to kind of sort of mimic human creativity? We don't want pastiche. But on the other hand, sometimes when it's trying to do something similar to a human, that helps us to understand the structures that are underlying the things that we're making. Actually, I start the chapter looking at literature and AI with a wonderful short story by Roald Dahl, The Tales of the Unexpected. These are stories I used to love as a kid. They were on the BBC and things. And this is a story of the let's see what he called it. It was the
great
automatic grammatizer. Yeah. And this is the idea. And the person who writes this, he's a hopeless writer, but he kind of realizes that a lot of literature has kind of patterns and rules to it, and he thinks that he can implement that, and he produces this machine, and all the authors then get horrified at how good it is, and they basically pay him to pretend that it's still them that's writing the novels. So there's certainly a lot of structure there, but there's certainly a lot else. And I think it was very interesting when I wrote this book, because I was sort of expecting that the written word would be somehow the easiest to replicate, because I thought there would be these kind of rules to how sentences are put together, rules for one learns kind of rules of structure, only 7 different stories basically to be told, so we've got a template there. And I thought music would also be very susceptible, because as you've already alluded to, the idea of pattern is very important in music. In fact, we're going to talk a little bit more about this tomorrow afternoon in a session to focus on technology and music, which you're going to take part in. So come and listen to some more of that. But I thought that the visual world would actually be the hardest, because that's always been the real major challenge for artificial intelligence, is understanding what's in a picture. If you think about it, the written word and music are very linear in quality. And so there's an idea that you could use a predictive, we already have this, a predictive text. It begins to learn what sort of things you say after another thing, and so it can make some guesses. Music as well, certain particular sequences of notes for a particular composer will often be followed by a similar sort of sound world. And whilst the picture is, it's not got a linear character to it. It's much harder to navigate pixel by pixel. That never worked. So the surprise for me was when I researched this book and wrote it, was that the visual world, machine learning that's been its great success, is that although we don't have to write top-down code to analyze pixel by pixel and say, well, that's a picture of a Christmas tree or something, it learns through being given lots of data. So because we have a rich digital world now of images, there's a lot to it to learn on. And because it can recognize images, it seems to be actually quite good at creating images. And music as well has been quite successful. And the written word, really surprisingly bad. I mean, that said, there have been some great successes on the short term. So a small scale works like the poems I read you, or short form journalism. So some very interesting examples where the power of this technology, for example, fantasy football, you choose your own particular football team, and people have been able to write AI which will write you football reports on your team. So there's no way a human could do that, because we all have different football teams. But to get a bespoke football report for how your fantasy football team has done this weekend, I think is a great use of the technology. But then we've seen some very bad uses just recently. A load of journalists were laid off last week by Microsoft, who said, we think our AI can curate our and put together our news more successfully. But I don't know whether people picked up the news story this morning, but they made a terrible mistake about putting the wrong picture of somebody in a news story, which caused a lot of anger. But there's something interesting about that story, because of course the assumption at first was that it's a human had made that mistake, and then it turned out to be the AI which had used the wrong picture. One of they mixed up two members of I think Little Mix, but we tend to judge AI much more harshly than humans, because humans have been making those more sort of mistakes for ages. I mean, it's like driverless cars. As soon as a driverless car runs over somebody, the technology is like terrible, and we should never use it. But actually, driverless cars have been far safer than putting a human behind. But we judge AI, maybe justifiably so, with it's got to pass much higher standards to sort of be implemented than than humans.
But I mean, that's one of the things that I think, to be fair, is definitely a much more common narrative now than even just a couple of years ago around AI, which is AI is a tool that accentuates humans, the good bits, the bads, the biases, the inequities, and all these sorts of things. I mean, what you're referring to this morning was it was two interracial people, women who were mixed up, and of course that reopens, rightly so, the conversation around bias within algorithms. But as you rightly pointed out, that's not new to AI. To bring that back, this idea of like accentuation of humans, and bring it back a little bit to this idea of creativity. I think, when I was reading your book, I was seeing that quite a lot of the examples that you were giving was AI kind of as a tool for helping a human. So maybe helping analyze a painting, or, seeing whether it was fake or not, or helping a musician take the next step based on what they'd already done before. Is that different than, because I think this idea of being creative, you can say that, we all build upon what we already know. Are we really inherently creative even as humans? But I think when we put that question onto a machine and go, well, it's kind of just basing on other things, it's not actually being creative. Or is it? What does that mean in terms of accentuation versus true creativity?
I think this is really interesting. And in some sense, towards the end of the book, I pick up a different kind of definition of creativity, not that kind of very functional one that Margaret Bowden comes up with, but I rather like Carl Rogers, the psychologist's idea that creativity is the tools humans have developed in order to understand our internal conscious worlds. And what is, I think, for me, the word intention was one that sort of really distinguished the AI from the human. The AI has no intention to play a game of Go. It's being told by a human to engage with Lisa Doll to play that game. Our urge to create, I think, comes from our urge to, first of all, explore our own internal world and our relationship to the world around us, but also to share our conscious minds with another. I mean, it's sort of almost trying to answer one of the great scientific problems, the hard problem of consciousness, the fact that I can never get inside your consciousness to feel like what it's like to be you. So we try and find as many tools to kind of understand, is my pain anything like your pain? So I think our art, I would speculate in the book actually that I think creativity and consciousness may have emerged in humans at a very similar period. I mean, we sort of see, humans making tools 200,000 years ago, but 40,000 years ago is when we start to see sort of creative acts, the hand and the paint on the wall, a very existential statement about my presence there. So I think that this is key. It's almost like our best fMRI scanner to understand internal worlds. That's why I write a novel, to try and share. Not that I've written a novel, but that's why. And many artists have talked about that. I have a quote in the book by George Eliot talking about art is the closest thing to kind of what it means to be human. So for me, you see, that will be interesting, because I think at the moment, you're right, this is a tool to try and stimulate our own creativity, these tools. And that's, I think, great, because frankly, I think as humans, we tend to start behaving more like machines than creative humans. We get very stuck in particular modes of operation. So, for example, the jazz musician you mentioned, he said, I just got stuck in a particular style that I was playing, and the AI helped me to reveal that the material I had there had so much more potential. And I think that for me, that's one of the interesting things, seeing there's a kind of what if machine, which has been suggesting kind of ideas for narratives. So a lot of what if you could talk to animals, and you've got Dr. Dolittle. So I think a lot of beginnings of stories are, what if this could be like that? And so there have been very interesting analysis by a team down in Goldsmiths who do wonderful stuff on creativity and AI, sort of what if machine that they call WIM, which is kind of exploring possibilities for stories, and it learns what stories we kind of like, and then suggests some new ones. And so I think that's exciting, but ultimately I think there's something emerging here which is really important, which is code is becoming so complex because of this learning process. So we actually don't understand really how it's making its decisions, and it's so complex it can't articulate itself why it offered the job to this person and not that person. And so trying to understand this idea of bias inside there, we need tools to examine the code to understand quite its thought process. And so I think this is the most exciting role of AI creativity, is that, creativity, I think, was meant to, is our way of exploring our own minds. So why not use the AI creativity to help us understand perhaps the decision-making process of code? And so I think, that for me, to use it as a tool to understand this new thing which is emerging, I think is really interesting. And there's I think a really interesting story, a literature story, since we're talking about Alexa winning the Nobel Prize, which is it's called Scheherazade IF, Interactive Fiction. So Scheherazade is, of course, a story all about storytelling and survival, coming up with 1,001 stories to tell. But this is this AI learns on human stories. So it's given a lot of human stories about how humans make decisions in a story about what direction they're going to go. And then it's given a story it's got to tell itself, and it's got to make choices. Actually, it's rather similar to those books I really loved as a kid, where they're kind of, you get to choose the story, turn to page 52 if you want to go in the attic, or are you going to go down in the cellar? That's page 74. A bit like Bandersnatch, Black Mirror comes up. You can make your own Black Mirror. And so the AI has learnt on our human stories, and then has to tell its own story and make its choices through this kind of web of possibilities, this tree of possibilities. And what's so fascinating about the project is that the story it ultimately ends up telling, we recognize as a much more humane sort of story than an AI that has done no learning on our storytelling and has been just left to make kind of almost random choices. And then you get a very dystopic, rather frightening sort of narrative, which we don't recognize at all. So here, I think, one of the things we want is to create an empathetic AI. We want an AI that's on our side, that understands us. We want to understand it. We want it to understand us. we don't want a competitor, we want a collaborator. We want something that is going to help us become more creative, that's going to push the boundaries in the right way. And for me, that was so fascinating. This Scheherazade IF, by learning on human stories, we've got an AI that almost, I mean, one can't talk about empathy, of course, because there's no internal emotional world yet. But I think that, that has a very positive aspect, that our stories might help AI to be on our side.
Yeah, so I want to talk a little bit about maths, because I think one of the big questions I always have when we talk about creativity and AI is, surely it's the act of creating that is the thing of value, as opposed to necessarily the thing that you've made at the end, or at least there's value in both, right? And with mathematics, so I studied pure mathematics at university, and actually I didn't say this to you yesterday, but you were actually the inspiration for that. I watched Story of Maths on BBC, and I read Music of the Primes, and I applied to study pure maths
so
at university.
Nice to hear. No,
so yeah, and I suppose I want to build on that to make the point that a lot of people question pure mathematics. People who do pure mathematics know that it's highly creative. It's much closer to art than science. It's quite philosophical. You're kind of away in your own wee world thinking, and the joy of proof, the joy of seeing the clever switch is, I'm getting tingles even thinking about it. It's an amazing process.
I can see, yeah.
Yeah, and so you know what I'm talking about, and it's not everyone always gets that. But I wondered if you could talk a little bit about how it feels for you to do maths, and the idea of AI being part of that, and does it feel like it might take away from it? 'Cause I think it's the same question that a lot of artists and musicians and writers have. It's not just about the end product. It's not about productivity. It's about the act of doing that makes us human, not just what's at the other side.
Absolutely. It's very interesting, because I've got on my table right now the one of the things which inspired me to become a mathematician, which is A Mathematician's Apology, which is a book by a Cambridge mathematician. And in this book, he talks absolutely about this idea that mathematics is, he says mathematics is like a painter or a poet or a maker of patterns. And one of the very strong narratives in my book is looking at whether AI could do mathematics, because I think many people feel, well, mathematics is highly logical. It's like playing a game of chess, logical moves that you can make. And so surely that's perfect for a piece of AI to do. And you see, I think you've absolutely hit on it. It's this idea of the emotional response is incredibly important in mathematics. And I use one of my favorite short story writers is Borges, and he writes this beautiful story called The Library of Babel, which is a library which contains every book that it's possible to write there in this library. So it seems like it contains everything. When you think about it, it actually contains nothing, because no choices have been made. And I think that's what's important, that a piece of AI could churn out every piece of literature given enough time. It could churn through like a machine, proving theorems. But we make choices of the theorems that we want to talk about in our seminars and publish in our journals. And those choices are based very much on an emotional reaction. So a lot of people compare maths and music because of the kind of very abstract nature and patterns. But I think that mathematics and storytelling actually have a lot more in common. That I feel like a mathematician is a storyteller. That we are, our characters are numbers and geometries, but we want to take people on a journey in a proof. So absolutely, it's not about just the last chord, the last line, the QED. What's exciting is the journey that you go on, and you want those surprises. The best mathematics is the ones which kind of, you don't know how this thing is going to turn into the thing you're claiming it will be by the end, and that kind of aha moment when you suddenly get why there's this transformation. Now, I did an event with Ben Ockrey, the novelist, and we were looking at the idea that mathematics and narrative in fiction writing actually have a lot in common. And we saw that, a lot of the tools, Roland Barthes talks about different codes for creating narrative, the hermeneutic code, the idea of setting up expectation, which you will then resolve towards the end of the story, and you carry on reading. What's making you carry on reading? And maybe sort of it's a more local suspense. Those are exactly the same things which we use in mathematics to make something exciting. So I was really saw a lot of resonance between storytelling and writing proofs, which is why I was so interested to look particularly at how good is AI at telling stories, and to see that actually, although it's very good at short form writing, and in fact 350 words of my book is written by a piece of AI, and to prove how good it is, nobody has yet picked up.
Not one person has.
Not even my editor. My editor doesn't even know.
I didn't. When I read that bit in the book, I was like, should I go back and read everything
exactly.
before this to see if I can work it out?
I think it's incredibly obvious because it's such bad writing at that point, which made me think, oh gosh, maybe that's the problem, that it's not the rest of my writing that's... Anyway, there's a bottle of a claret from New College's cellar for the first person who identifies which 350 words is written by AI. So although AI is very good at this short form, it's really not good at the long form. And that kind of encouraged me that if it can't write stories, it's not going to be able to do grand proofs. It can do sort of local bits of mathematics. And it's very interesting, this idea of the temporal quality of narrative and also the temporal quality of music is something that AI is finding very difficult to kind of get at. And so it can produce things which locally make sense, but the global structure, it's somehow missing that. I mean, it's sorry. I'll actually, can I read you a little bit of?
Yeah, I was going to say, give us the example.
There's a wonderful attempt to create an eighth Harry Potter novel. A group of coders and artists in America called Botnik have been kind of using AI to try and create an eighth volume because they love Harry Potter and disappointed there are only 7 volumes. So, there's a lot of material for the AI to learn on. J.K. Rowling wrote quite a lot. And so they got this thing to learn on her style and the sort of stories it tells, and it starts off pretty well. So actually, I love the name of the book it came up with is Harry Potter and the what's it? Where is it? Harry Potter and what looked like a large pile of ash. Kind of a strange name for a title, but anyway, it starts off quite well. It says magic. It was something that Harry Potter thought was very good. So good. It's picked out the magic as a major theme in these books. Mm-hmm. Leathery sheets of rain lashed at Harry's ghost as he walked across the grounds towards the castle. I think that's
fair. Yeah,
it's a lovely image. I mean, leathery sheets of rain. I would never have come up with the idea of rain being leathery. So anyway, but from that point on, it starts to lose the plot. Ron was standing there and doing a kind of frenzied tap dance. He saw Harry and immediately began to eat Hermione's family. Ron's Ron shirt was just as bad as Ron himself. So the thing has really started to lose the plot, and although each sentence makes sense in its own right, put them together, and you've wiped out Hermione's family, and so I think that although there's some wonderful examples of things being quite good on the short term, it's the idea of large structure. Weirdly, it's finding very difficult.
Well, one of the other examples in the book that really, I think, brought home as well the challenge in AI with storytelling, not just temporal, but also context. And this is something that we do hear a lot about with natural language processing. So the Winograd challenges you write about. And these are really short. I'm going to read out the one that I thought was great. And these are different challenges that AI seems to stumble upon. Or stumble on, rather. This one is, the trophy doesn't fit into the brown suitcase because it's too small. What is too small? And I thought that was brilliant. When I saw that, I thought, yeah, what is too small? Even though I'd read the sentence understanding it. And then when you asked me the question, I was like, oh, wait, what? Oh, yeah, no, it's the suitcase, obviously. But you're saying
exactly.
that the AI
my favorite one is, I think it's one of the first ones Winograd came up with, which is the government banned the protesters from marching because they feared violence. But if you change the they feared to they advocated violence, the meaning of they swaps. But we humans can identify immediately that they feared violence the day as government, they advocated violence we think is the protesters. But where is that knowledge coming from? It's not just from language and grammar and meaning of words. It shows that there's a hugely richer data set, which is feeding into our creativity, which is history, sociology, just so many more things. And I think at the moment that's what's kind of missing in AI creativity, that we've got very narrow data sets that we're giving it. So, for example, in music, we'll give it all the works of Bach to learn on, to create a piece of Bach, but we won't realize that actually Bach was fascinated in language and the character of English versus French versus Italian, and that would influence his writing. And so something like the English suites are not just a bunch of notes, they're actually trying to mimic the way English sounds. And so if you don't put that in the data set to learn from, you're going to get a very narrow output that is missing so much. And I think the Winograd challenges reveal that the creation of language is so much richer than just looking at language as data and the meanings of words and how they're put together. There's so much more, as you say, richer context. So I think, and I think that'll be interesting going forward, is enriching the data set. So if you're making music, don't just restrict your learning data sets that the AI is learning on to just music. Put something else interesting in there as well. And we're starting to see that, because this is, I talked in the book about 3 different sorts of creativity: exploratory creativity, pushing things to their limits, and then the idea of combinational creativity, combining things from different areas, and that, like fusion cooking or something, taking the ingredients from Asia but cooking them in a French way or something like that. And transformational creativity, thinking outside the box. But I think this combinational creativity is something that AI is beginning to explore, about taking a style from one place and then implementing it in a completely different area. And I think that's something it's actually quite good at. That's Margaret Bowden's classification. She was actually, I was on a committee with her at the Royal Society when we were looking at the impact of machine learning on society. And so I talked to her, and also Demis Hassabis, who was the creator of AlphaGo. So they kind of both inspired me on this journey to write the book.
So we've got only 3 minutes left, and I want to build on finally this impact on society thing. We've touched on it a lot, but I want to ask one specific question, and just so people know, we're going to be doing a Q&A. So all of your questions on Slido and any more that you might come up with between 11 and 11:30. So make sure to join that, and I'll get to all your questions. Don't worry, I've not been ignoring you. So this part on impact on society. So you touched on it a little bit earlier on, but one thing that I was thinking about lots during the book was, does it matter if you know if something has been done by an AI versus a person? So when you're looking at a painting and you feel something, is it just the painting itself, or is it also you reflecting on the fact that somebody has created it? And I think in the music chapter, I think you kind of put forward a quite good argument that actually it's a lot to do with the listener putting their own emotions into the structure. It's almost like they've been given space to play, shall we say, with their own emotions. And I'm curious as to what you think about, if AI does a good job of letting us feel stuff, then it's a good thing, right? But even if it does replace the artists or whatever.
I think it's never going to replace the artist. And most of the time, I think this is an important kind of message to end on, that this is, and it's a message I try to end on the book, which is, this is about being a collaboration and stimulating our own creativity more. And one has to remember that, if you're reacting to something that, and then you learn it's made by a piece of AI, often you feel very cheated. But you have to remember that AI has very often learned on our own emotional world. So we're getting some sort of interesting new telescope looking into our emotional world and reflecting it back to us. So I think we shouldn't feel threatened or upset by that kind of reaction. And I think, we kicked off with that sort of Turing test, and I think in a way I'd like to get away from that. I thought it was just a fun way to sort of kick off engaging people. But I think the important thing is, actually it's quite interesting to know if something's being created by AI, because it actually tells us to understand how to understand the AI. And I think that's the exciting thing, using these tools to understand how AI is thinking and the impact it's going to have on our society.
And if it makes us feel good or makes us feel something in the process of that, then, that's a bonus, if anything, right?
Yeah, exactly.
Awesome. Cool, Marcus. Well, thank you so much for chatting with me and indulging me with all of your questions. As I said earlier on, we are going to jump into Q&A at 11 o'clock till 11:30. So half an hour of your questions that I will field and put to Marcus and let you guys get all of your views. And thank you so much for joining us for this chat already. And we'll see you at the Q&A in 15 minutes.
know, the climate is Our pioneering platform gives decision makers personalized, real-time insight into climate risk to their specific
Hello everyone, welcome back to the cutting edge stage here at Cognition X, or rather here online, wherever you're dialing in from at CogX. The next session I'm really excited about, which I'm sure you guys are too now that you're here ready to watch. It's all around exponential technologies for planetary health. And I'm actually just going to pass straight on to the moderator of the discussion, which today is Libby Kinsey. Please join me in welcoming Libby to your screen.
Good afternoon, and thank you so much for joining us for this session. My name's Libby Kinsey. I'm an independent researcher and consultant in machine learning, and also technologist at Digital Catapult. This session is about the potential for exponential technologies, and I guess really machine learning to be impactful in big problems for climate change and the environment. Our two speakers are going to describe how they are turning potential to reality by applying machine learning to specific problems in climate change mitigation and adaptation. We'll then move on to do a discussion about the use of machine learning in these areas, what works, what doesn't, the challenges, and how to get involved. This session is for you if you are a machine learning specialist who you're motivated to put your expertise to use, but not quite sure how to do this. Or if you're wondering what's hype and what's not. Or if you're interested in how to move from problem identification to reality. So what are the special challenges for building teams, for funding, collaborating and deploying in this area? With no further ado, let's get started. Jack Kelly is co-founder of Open Climate Fix. Over to you, Jack.
Thank you very much, Libby. Hello, everyone. As Libby said, I'm Jack Kelly, co-founder of Open Climate Fix. And I'd like to talk to you a bit about my non-profit, Open Climate Fix, and about using machine learning to try and help balance the electricity system. So I'm sure I don't need to go through this slide for this audience, but just to really ram home this point, we have to reduce emissions really, really rapidly in order to keep warming to below 1.5 degrees C. So at the top of this graph, you can see we currently emit about 40 gigatons, or about 40 billion tons of CO2 per year. And we need to get that down to about net zero by about 2040. So in 20 years, we need to reduce emissions from 40 billion tons a year to about net zero. And that is a huge task, and we need to move very quickly. There's no time to waste. As this graph shows, the later we start reducing, the more rapidly we need to reduce emissions, because what matters here is the total stock of CO2 in the atmosphere, which here is the area under the curve. So the later we leave it, the more rapidly we need to reduce emissions. So yes, we must move quickly, and we must focus on solutions which the climate cares about. There are lots of things out there which are easy to talk about, which get lots of retweets and get lots of press coverage, but the climate ultimately doesn't care. So we need to stay laser focused on interventions that the climate will care about, where there's really sizable emissions reductions. So in Open Climate Fix, we certainly can't claim to be doing anything more than just taking a very small part of this problem and trying to help. But the problem that we're focused on is described in this picture. So on the one hand, we have the energy industry on the left, and on the other hand, we have researchers. Many of these researchers would love to help the energy industry to reduce emissions, and many people in the energy industry would love researchers to help. But there is this enormous mountain of pain between the energy industry and researchers. So to be concrete, that's things like it's very hard to get access to data. It's very hard to know which problems industry really cares about. It's hard for researchers to test those ideas out in the energy industry. And in Open Climate Fix, we're trying to help there. So yes, there's evidence there might be of the order of thousands of researchers who want to help reduce emissions, but they can't because, like we said, can't get the data, can't test it in the real world, and don't know which problems to solve. And this, of course, is both a terrible waste of talent and is also a terrible waste of an opportunity to reduce emissions quickly. So ultimately, what we want to help with in Open Climate Fix is to drill a hole through this mountain of pain and help the energy industry and researchers to talk together and to work on solutions rapidly. So our model is a completely open model. We're a non-profit. And so what we want to help with is, first of all, identifying a problem that industry cares about, releasing data and problem specifications and tools, hopefully engage many researchers to develop solutions, facilitate building industry-ready, open source, minimal viable products. It's building things that industry cares about, and so we can test these things in industry. And then we very much want other companies to take that code, take that research, and implement it for themselves. We can better open up energy data. And the second is using machine learning to help forecast solar electricity power generation. And both of these projects ultimately are trying to help balance the electricity grid. So let me spend a few minutes just talking about balancing the electricity grid. So on your screens now, you can see a picture of the UK National Grid Electricity System Operator Control Room. And in a sense, these guys have a very clear task, which is balancing electricity supply and demand moment by moment. So the physics of the grid dictate that at every moment, supply must exactly match demand. And at the moment, it's hard to store significant quantities of electricity. And it also turns out that many of our generators take hours to spin up from cold. So we need to be able to forecast demand and renewable supply ahead of time. And ultimately, what these folks are, one of their main tasks is making sure that there's enough headroom at on the system at any moment to mean that automated systems can then modulate supply and demand within that headroom. So in particular, they will make sure that there's enough spinning reserve, which is just spinning generators like the gas turbine you can see on this slide. And these will be deliberately throttled back. So instead of operating at their max capacity, they might be operating at 50% of their capacity. And in that state, they can ramp up really quickly and help fill in any gaps in generation. So for example, if it's a sunny day and we have lots of solar electricity generation and a large cloud comes along and wipes out a gigawatt of solar electricity generation, then that generation needs to be replaced very, very rapidly by this spinning reserve. So if we had better forecasts for electricity supply from these renewable sources like solar electricity generation, then we might need less spinning reserve. And crucially, these generators are a lot less fuel efficient when they are operating at, say, 50%. So it would be better to have a smaller number of generators running at near to max capacity than a large number of generators operating throttled back. So I'm going to briefly talk about our main project at the moment, which is using machine learning to help forecast solar electricity generation. So we believe that better solar electricity forecasts should reduce costs and carbon emissions, primarily by reducing the amount of spinning reserve that we need on the system. But there are other mechanisms by which better solar forecasts might help reduce emissions. And this video on your screens at the moment shows two of the main data sets that we're working with. So there's satellite imagery. This is from a geostationary satellite, which takes an image every 5 minutes to the same point on the planet. And that's showing us clouds. And then overlaid on top of that are these circles, and each circle represents one solar electricity system in the UK. And the colour of the circle represents the amount of electricity that system is generating. And you can see something that isn't particularly surprising, which is that when clouds move over a solar panel, it reduces its electricity output. And our task in trying to forecast this is effectively like pressing pause on this video at a particular time point, and then using machine learning and weather predictions to try and predict what's going to happen both to the clouds and the solar electricity generation over the next few hours. And we hope that people like the electricity system operators will find this useful to help them reduce spinning reserve and so to reduce emissions. So how do we forecast solar electricity generation? So there's really two main tasks, and then we combine those two tasks. So the first task is around nowcasting the amount of electricity generation for any location. So where nowcast is a slightly peculiar term, which just means forecast for the next few hours. And so the way that we are investigating to do this is we want to train machine learning systems on many years of satellite imagery and numerical weather predictions to basically learn the atmospheric physics that are relevant for understanding how much sunlight can move through the atmosphere. So that's one part of it. And another part is, of course, trying to predict the movement of clouds. And you can do that fairly well just by looking at the wind speed and direction for each pixel of cloud, and then moving that pixel of cloud according to that wind speed and direction. And that works fairly well for very short time horizon forecasts. But to go much further than that, you really need to learn the evolution of clouds, the way that they grow and shrink, the way that they condense from water vapor into little droplets of water or ice, and the way they evaporate away into nothing. That's part of what we're doing. Another part is just figuring out where all the solar systems are. So just drawing a map of where all the existing PV capacity is, where PV is photovoltaic. And this is perhaps surprising to folks that aren't intimately related to this field. Most people probably think that we already know where the capacity is. And there are some data sets which claim to tell us where the PV systems are, but there are pretty big gaps in these data sets. So we need to do a better job of both merging existing data sets and also of using computer vision on satellite imagery and the wisdom of the crowd and that sort of thing to try and map more of these PV systems. And for example, we've been doing projects with OpenStreetMap on trying to map the location of these PV systems. So once you have both, once you have a map, and once you know where, you know how much sunlight is going to fall on each bit of the Earth in the next few hours, you can combine these to forecast power generation. And so to just give one really concrete example of a machine learning project that we're doing, here what we're trying to do is just learn a mapping from satellite imagery to PV yield, where PV yield is just the output in kilowatts divided by the max output. So you get a value between 0 and 1. So here we're not interested in forecasting the future. We're just interested at taking a satellite image at, say, midday and inferring what the PV yield would be for a specific PV system at midday. And here, unsurprisingly, we're using convolutional neural nets that take a rectangle of rectangle of satellite imagery and predict the PV output for a single PV system. And here are some very early results. So if we look at the top subplot, so on the x-axis is time in 5-minute increments. Sorry about the slightly ugly x-axis. And on the y-axis is PV yield from 0 to 1. And in orange is the ground truth, the actual PV output. And in blue is the inferred PV output from our neural net. And you can see at this 5-minute interval, it does a reasonably good job, but it fails to get these very high frequency changes, which we think are due to small clouds moving across. But if we take a rolling average, so here's an hourly rolling mean, we get a much better match, although sometimes it still goes a bit skew if, and we're investigating why. So this is just the very first step. There's loads to be done to improve performance, loads to be done to try and predict the future and use numerical weather predictions, but we're moving in that direction. And we hope to have a kind of minimal viable product of a solar forecasting API in the public domain, maybe by the end of the year, but please don't hold me to that too much. Cool, and I will finish there and hand back to Libby. Thank you very much.
Thank you very much, Jack. Next presentation is from Iggy Bassi, who is CEO and founder of Servest. But before handing over to him, there's a short animation.
We all know the climate is changing, but who knows what that will mean for me? Or you? For businesses? Or communities? Servest is creating earth science AI to enable decisions that protect our assets, including the one we all share. Our pioneering platform gives decision makers personalized, real-time insight into climate risk to their specific assets, increasing their resilience. Here's how. You've got an asset. Like all assets, it's vulnerable to climate volatility. Until now, to calculate risk, you'd have to review huge quantities of data, mostly historic, siloed, and none of it specific to you. Earth Science AI harmonizes vast and disparate data sources, interpreted by leading-edge machine learning, with best-in-class scientific modeling. For the first time, you can locate your exact asset, monitor it for climate signals in real time, and anticipate short-term shocks and long-range change. Soon, you'll be able to determine science-based risk ratings for disclosure compliance. Insights are shareable with stakeholders, and decision makers with multiple assets can build a complete understanding of their portfolio. At the heart of our mission is the democratization and transparency of climate risk to global assets. We don't have much time. We need better decisions now, and believe in the power of the tools we're building to help that happen fast.
So thank you very much, Libby. And also Jack. So just want to spend a few minutes talking about Servest. So if somebody could just load up the presentation for me, that'd be great. Take it to the first page. Just going to walk through just a handful of slides just to give you some flavor of some of the work that we're doing and also the problem around data that we also find as well. So if you could just go to the next slide. I think Jack is right. We've had about 10,000 years of fairly stable climate. I think what we've seen the last 100 years or so is just a puncturing of that order. So I think the heart of the problem that we spend our machine learning time on is say, how do we deal with this volatility? Volatility is rising everywhere. It's becoming far more expensive. And that has a major impact in terms of how do we think about generating returns, whether they're economic returns, social returns, and also how do we think about ecological returns over time. So if you look at the world's assets, we have about $1 trillion worth of assets which are considered at risk just by the largest 500 companies. We're seeing about 100 million climate refugees by 2050 because of climate and resource conflicts. About 50% of the world's population will be living in very water resource stressed areas by 2025. So with all this rising volatility, what we can't quite figure out is with all the world's data, how can we make more sense of that data? If you just go to the next slide. So our work over the last 3 or 4 years has just found this massive gap between the awareness of the climate problem and how do people take everyday action into their decisions. And there are 3 primary reasons why people get stuck. The first one, as sort of Jack said, is data. Where we don't, even though we have lots of data, we have lots of the same data in the world, and we have a lack of what we call labeled data. And also, when you're thinking about the climate problem, you're fusing together probably a dozen different sciences together. So when you're asking large corporates or governments or everyday citizens to think about climate change, it's remarkably difficult for people to translate all this complex science, complex data. It's deeply fragmented. So people find that they're just not able to take the action that they want. I mean, there's some very easy wins that companies have taken around decarbonization, thinking about emissions. But in terms of climate volatility, we still find that even the most well-capitalized companies on Earth are not really thinking about the action that's going to drive long-term change, systemic change. How do they build more resilient assets? I think a second big area is there are no standards. Nobody quite knows how to measure climate risk. If you're looking at an asset in Argentina, if you're looking at a forestry in France, if you're looking at a nuclear plant in the USA, we haven't quite figured out a standardized methodology for the world. We are remarkably good at measuring so many things, but climate risk and climate volatility on a standardized basis is very difficult, which makes it very difficult for capital markets, insurance companies to think about, well, how do I assess one asset against another asset? How do I compare and contrast different risk profiles? I think the second area is largely around people's belief system. People have a horrible tendency to believe it's not going to happen to them. For many people, the climate problem is a psychologically distant problem. It's not something that's around the corner until it happens, of course, right? So, and some of that's just driven by climate denial, belief systems. So when we started this journey about 4 years ago, I had just sold a fairly large agribusiness that I had set up. I said, how can we figure out this complexity around data? How do we make a standard approach? But then how do we get people to really change their minds? If you just go to the next slide. One term that I found very problematic in the marketplace was actually just the term climate change. People have very strong emotions to this term, again, driven by their belief systems. So we framed the problem as a climate security problem. Ultimately, all these assets that generate our returns, our livelihoods, our ecological security, our social security, we should start classifying climate security as the primary problem. And people have different incentives. People think and they respond cognitively differently to their assets, their economic livelihood, their food security, for instance. So we've started using this term now with some early clients, and it seems to be working very well. It's actually changed the way people think about it because there's a visceral sense around people's assets rather than the psychological distance of climate change in the future. Next slide. So what we try to do to say that most of the world's science sits at a very high level, whether that's at a temporal resolution, a spatial resolution, and most of these climate sciences tend to operate at very different uncertainties, very different scales. So we've been trying to figure out how do we use machine learning, AI, statistical analysis over the last couple of years to bring all this together in a way that you can actually make decisions on your assets on a personalized basis. Now, that sounds rather grand, but there are 3 areas that we bring it together. One is machine learning, particularly to the use of Bayesian statistics, data engineering, and physical sciences. And we call it Earth Science AI. And through that, we bring the world's assets. So we try and gather as many assets as possible because there is no label data. So we have to classify quite a few assets by ourselves. And then we bring lots of the world's scientific outputs. What we don't do is generate brand new science. Most of the world's physics is well understood. It's just deeply fragmented in multiple different sciences, and it's never been brought together in a way that can support everyday climate decisions. If you just go to the next slide, so that Earth Science AI feeds into the world's assets. So by classifying all the world's assets, we can start automatically identifying assets and downscaling that automated climate science to start quantifying and standardizing climate risk. And there are several things that we look at. We first look at just your historic risk. We just baseline your risk first. I mean, we are often surprised at how many companies in the world do not actually know their historic position on risk. They don't know which lever has gone up, which one has stabilized, which one has gone down, which one is accelerating. So in many ways, most of the world's assets, the first thing that we can do with our platform is just get large governments, companies, large communities to start thinking about what's already my situation, what's my scorecard today, what's my baseline. And before we start thinking about forecasting, now we are moving towards forecasting from an hourly basis to a decadal basis, because every decision has a different time dimension. There are some people who need to make instant decisions. There are other decision categories that require multiple decades worth of forecasting. If you're going to build some of the power facilities that Jack was showing, for instance, you need to know what's going to happen in the next 30, 40 years. So to what degree of certainty can you bring if you're going to support a $500 million loan package, for instance? Then ultimately we get down to simulations. What happens if temperatures rise faster? If water changes suddenly, if the solar radiation patterns change, if cloud formations change massively, what's going to happen to the underlying assets that generate our livelihoods, our ecological returns? We have slowly started building up over the last 3 or 4 a large global inventory of assets, and these are built environment assets, everything from power plants to buildings, schools, hospitals, forestry, everything to rural assets, which are fields, agricultural fields, forestry, and river. To date, we have just over 500 million assets, which have largely been classified through machine learning algorithms. So we can bring all those onto a centralized platform. Just go to the next slide. Then all this feeds onto a centralized digital platform, and people can then generate that data into an API. But then, what we ultimately want is for people not to say, well, we didn't know about climate risk. We don't know how to make a climate decision. We're saying, you can start integrating climate risk into your everyday decisions, whether they are credit decisions, they're short-term decisions in terms of supply chain, insurance pricing, everything through to long-term, my decarbonization investments, my M&As, my capital expenditures, where do I put the next factory, for instance, right? Over time, we fundamentally believe this platform should be open. And I think it's only by giving the world this type of data at an asset level on a real-time basis that people can start beginning to make more climate smart decisions. Ultimately, it has to be an independent platform, and it has to be shareable. And that's what we are trying to build. If you just go to the next page. I think there's been a lot of push in the last 10 years for people to start disclosing. But again, I think just quantifying your your carbon and your emission output isn't enough. So we'd like to use the power of digital technology with the power of ML to make assets simple. So you can extract your assets from a digital platform and start monitoring your historic, forward risk, and your simulations. Now, there will come a time when this type of climate literacy will have to be so obvious and so seamless into everyday decisions. So people like insurance companies and credit companies and government regulators will be able to understand and assess all your portfolio of assets on Earth, anywhere on Earth, and they can look at different timescales, they can look at different scenarios. Because in the next 4 or 5 years, if we continue suffering from the climate losses, which are now running into $200 to $300 billion every year in terms of insurance payouts, there will come a time when insurance companies will not fund businesses. They'll say, the risk has simply become too large. We can't quantify this risk, or we can't even tell you how to adapt to a different climate world. So part of the learning here is to say, how can I, climate-proof my asset over time? What best adaptations can I make over time over my asset? Next, and I'll wrap up fairly soon. We're on a fairly simple mission. We want to empower everyone to make the best possible decisions through our Earth Science AI. I think I've been working in climate for about 10 years. The excuse that I hate most is we just don't have the tools. We just don't know how to do it, or the science is too complex, right? So we've spent the last 4 years trying to debunk the science in a way that makes it as easy. Take all that climate complexity and turn it into a very simple service for you. Next page. We're a very small team in London. Just on the next slide, please. We're a small team of 30 people. We've done a bunch of work for some very large companies, testing and showing them the power of early detection on some climatic events, weather events, working with some interesting partners, and being on a bunch of interesting programs. Just in the interest of time, I'll just wrap up there. Just one more slide I have. And we need to think about this slide here. So maybe, Libby, you can think about some questions around, well, COVID has hit us, recession's hitting us, but the big wave of climate is just behind it. Thank you very much.
I will do. Thank you very much indeed, Iggy. So if we could have Jack back as well, we'll move on now to the discussion part. And what struck me about both of your presentations, which was by design, so obviously the case, was that you're both have been very concrete and careful in applying machine learning to climate change problems. And I just wanted to try and get this question of techno-solutionism out of the way, because that's a charge that is made against enthusiasts in machine learning that are motivated to get involved, but perhaps don't know which problems to best use their skills. What is an appropriate problem in climate for machine learning to be at least part of the solution, and how do you go about identifying one? Jack. both large and take a breath.
Big question, Libby.
Yeah.
I like to start as I mean to go on, Iggy.
Yeah, small. So yes, first of all, I completely take the point that we mustn't be overly focused on technical solutions. Clearly, to achieve the kind of carbon emission reductions that are required, we also need behavior change. We need to use less stuff, fly less, that sort of thing. And I guess the main reason that I'm working on tech and not behavior change is because I have no idea how to alter behavior. And I have tried briefly, and it just looks it looks very, very difficult. So I think my aim is to work on tech that might help reduce emissions in the relatively near term, to give people that are much smarter than me time to figure out how to change behavior. Now, I haven't answered your question yet, how to figure out which things to work on. I think it's really, really hard to come up with a hard and fast rule without diving really, really deep into the domain. So to be specific about that, I think it's very hard to, ahead of time, predict the carbon emissions reductions that you should expect from a particular technological innovation, because you need to consider all sorts of things, not just the direct effect, but also if there's going to be rebounds. So for example, one of the challenges with increasing energy efficiency is that the economic incentives are such that if you tell a factory owner, hey, you can produce the same amount of stuff for less input, then they'll turn around and say, great, I want to produce more stuff for the same amount of input. So that's probably a climate loss. It's hard to see that's a climate win. So yes, that's a long rambling way to say, I don't know. It's really hard. You tell me, Libby.
Well, I guess I was hoping you might point us towards some domains in which there's large amounts of data, for instance.
Yeah.
Iggy, do you have anything to add to that question?
Yeah. So first of all, I fundamentally believe that technology in and of itself is not going to solve this problem. So everything that we do is designed to augment human decisions. But we do also need to recognize that human decision-making capability is not enough to look at the problems that we're actually facing. So I think that the climate problem is so large and so complex and changing in ways that, past history and past data doesn't always have the predictive power to look forward. So in many ways, we do need to augment technology. We need to understand, what are the limits of sort of human judgment, human decision making. I think there is an ethical dimension to the work that we do as well, and also what other work that other people should be doing is to think through the role of ethics. So the very first paper that we published as a team is to say there's going to be a lot of uses and misuses of climate data, climate intelligence. How do we think about an ethical framework for that data? I think it's really important we understand that it doesn't matter what new technology comes to the market, whether it's climate intelligence or fintech technology, there's always going to be people who are going to game the system, right? And we have to be super careful about that. And how do we think about, open data committees, I think people don't like black boxes. I think that's what we've learned over the last couple of years as well. A lot of AI companies, the first wave of AI ML companies, where they created too many proprietary technologies which were just too hidden. People didn't quite understand the algorithms, the data collection methodologies. I think there's a big pushback against just pure black boxes. People like explainable AI. And this becomes important in the climate realm, where we're really asking the public purse to finance lots of the decarbonization, the taxes, right? So I think proprietary methodologies are probably not going to work so well.
Thank you, Iggy. You've touched on a few things that I want to get into. And one of them is you've both mentioned that, and at least I think one of the things we've just agreed on is that machine learning is never the whole answer. And so you're working with both inside existing systems and with different domain expertise in each of your companies. I suspect that has challenges of its own in terms of how do you translate between different domains. Is that something you found? And if so, what are good ways to address those challenges? And I'm going to go to Iggy just to be fair this time.
So again, on day one, we realized that this is a problem that requires multiple experts. There's not a single team that can solve this problem. So on day one, we started working with some of the universities because they have different approaches to sort of modeling. They have different data sets that we can use. We're actually, from a product design point of view and from an ML problem point of view, bringing teams together from different disciplines early is really useful, because we have some brilliant statistical scientists, but they need to be able to understand what is the market really asking? How do people actually make decisions at the end of the day? So, because perfect models then have to map onto perfect decisions, and that really doesn't happen unless you bring the different disciplines together early. So we have different approaches. We have an awesome head of product and a CTO. He's been able to mix the teams together in such a way that really forced the curve of the ML modelers, the data scientists, and also the people who are facing the market every day. Because there are no perfect teams for this type of stuff.
Jack?
Totally agree with all of that. Yeah, absolutely spot on. So in general, I think domain expertise is extremely important in solving many of these problems, and that problems need to be, or we need to focus on problems that users care about, that the industry cares about. So there's kind of wicked combination of, we've got to build solutions that are genuinely useful and that industry makes their lives easier, whilst also reducing emissions and whilst also hopefully reducing costs. And indeed, one of the main motivations behind making Open Climate Fix a non-profit and doing everything openly is exactly so we can engage with as many domain experts as possible. I think our view is that machine learning is a great tool, but it is just a tool that's useful for solving problems. And in some ways, a real priority is figuring out the right problems to solve. And that has to be done in collaboration with domain experts and users. And often it's important to distinguish between users and the people that are actually going to commission a piece of work. So that's also a challenge.
I think it's fairly unique within the sort of climate space as well, because it's a political choice. The rate of decarbonization, the taxes, the carbon tax and the carbon pricing, these are fundamentally political choices. So it doesn't matter how good the ML modeling, the outcomes are, the predictive capability, ultimately it comes down to political choices. I mean, Paris is great, but Paris is also non-binding, right? We haven't seen that commitment level yet at a political level. These will remain political choices, I'm afraid.
So let's stick with this theme a little bit. Jack's just mentioned that Open Climate Fix is not a for-profit company. I think, Iggy, that Servest is a for-profit company, or perhaps a B Corp.
It's a B Corp too.
Okay.
Yeah. So our model is to say, let's have a freemium model where everybody could benefit from climate intelligence to a certain level in terms of resolution, temporal range of the actual forecasting. Because I've had the opportunity to work in Africa, Latin America, Europe. If we don't democratize this data in a way that's affordable and some level free, I'm afraid we're going to create this climate apartheid where some people who can afford the data, the risk data, will just privatize their data and optimize around their assets. But climate doesn't get solved on that basis. Fundamentally, everybody needs to raise the bar, right? So we make our platform as open as possible. There are obviously premium services. Do need to pay the bills one day. So we need to operate in a way that makes the business sustainable over time.
I think this is almost another of the problem, is it not? As Jack was saying, that maybe the commissioners of work are not the same people who are beneficiaries, or there may not be very much overlap. And trying to build a company, whether for profit or not, does require funding of some sort. I wondered if you could talk about how you are funded and how that might be different to traditional venture capital, or maybe the same, and what are the challenges there?
Sure. Fundamentally, I think capital needs to be mission aligned. We do have a strong mission. So I was very purposeful with the capital that we brought in. So I brought in, first of all, angel investors who were very committed to this mission. I was very fortunate enough last year to meet 2 European VC funds who also believed in how do we use technology to solve big problems at scale. So they've come on board now. We're just doing a financing round now. Again, existing investors have supported us. I think they understand the problem we're trying to solve and the approach that we're trying to take it. It's not easy, right? Because you are trying to create a brand new category called climate intelligence. Jack's doing exactly the same thing, trying to get people to think differently. When we go to large companies, we don't ask for the climate risk department. They don't exist, right? So suddenly you have to create this narrative to say, this is a big problem. There are brand new tools that you've never used before. This is how you use these tools. It takes time. And on top of that, you have a lot of uncertainty on the science. Science changes all the time. Different data sets come along. So you need a very rigorous scientific methodology. Then you have to productize that and then convince people to finance that. So it's really patient capital that you're looking for. Ultimately, it does require scalable capital. So we are looking for US investors for the next round of financing as well next year.
Jack, you haven't taken venture as far as I'm aware. How are you funding yourself?
That's right. So we are a company limited by guarantee. So we have no shares. So there's nothing for VCs to engage with. So we are funded at the moment by a grant from the European Space Agency to look into solar nowcasting, and another grant from Innovate UK to look at opening up energy data. And to the sort of looking to next year, we're keen to raise more funding, both grant funding, but also as we build out our solar forecasting tool, we want ultimately that to be financially sustainable. So the idea is that the code will be completely free, all the research will be completely open, but we will run a service, an API, and we'll try and make as much of that as cheap as possible, but we will charge for some of that to bring in some revenue. But one of the interesting things about solar nowcasting is, looks like we're pretty confident that it will reduce emissions, and we're pretty confident that it's not going to make billions. So it feels like quite a good thing for a non-profit to be working on, where it's something that's socially useful but won't bring in the returns that a VC would expect. And very briefly, that's partially because of this misalignment between saving money for the energy system and being able to bring in some of that reduced cost. So, for example, in the UK, we spend about £500 million a year balancing the electricity system. We think we can probably help reduce that by a reasonably large amount, but those costs are paid by the end users, not by the decision makers, and so it's hard to capture any of that value.
So I guess there are other issues as well, aren't there, with this disconnect or conflict between who the beneficiaries and the commissioners are, and I've lost my train of thought. I'm looking at the sidebar. What was I going to say? So this was about not funding, but business models and the distribution. So we're talking about complex systems. I've got it back. Where potentially the data sources that are required are fragmented, distributed, held by different people. Maybe the people are participating for different reasons. Mm-hmm. Do you see the need for some kind of coordinating either national or supranational body to try and ensure that those data sources are made available and that the different parties can collaborate effectively?
Yeah, so I think there's a great need for that. I think within the climate modeling fraternity, there has been quite a bit of harmonization over the last couple of years, but it's great to see the weather and the climate community moving closer together. I think there is greater discussion of that. I think over time, there is a pre-competitive space for, let's say, the insurance sector or the asset management sector to start sharing standards of data, right? Because I think then we can start comparing different assets in different parts of the world, different impacts in different parts of the world, if everybody had a common approach to at least the data. So if there is a co-op structure, is some sort of data depository structure, we'd be very open to that. And that's part of what we wrote about in terms of the ethics around climate data. If there's a certain pool of it that needs to be put together in the public trust, almost. And this becomes, again, more important given that the public are ultimately the sort of backers of last resort, as we've just seen with COVID. So I think you're going to see the same type of behavior within the climate risk world as well. Governments will ultimately be the last people to bail folks out. So getting policymakers to understand how to use climate intelligence, how to use different data in a pre-competitive space, I think would be most welcome.
Jack, are you seeing any signs of this coordination happening?
So we definitely need to make it easier to access a whole bunch of energy and climate data, although a lot of that's coming on stream already. Part of the answer there is quite likely to be more open standards. So rather than sort of trying to regulate it too much, defining sane open standards and conventions and sort of, as Gavin Starks at Icebreaker One would say, sort of preemptive licenses. So today, one of the big challenges of sharing data is that even if the board of a company say, yeah, cool, we're happy to give you data, just sign it off with our lawyer, it then takes another year and a half to go through the details with the lawyer. Whereas if there was just a standard license that everyone was familiar with, then that would take away all of that pain. So, for example, today when you go and read Wikipedia, you are, entirely comfortable that's under a Creative Commons license. Is that what I said? Yeah, I think it is. And people know what that means, and that works well. I think, that's one of the big parts of this.
Thank you. I'm being told we have 2 minutes left, so a quick fire final question for both of you to answer. What is your advice? What's the best thing to do for a machine learning specialist that wants to move into working on impactful problems in climate change?
So I think there are a few bodies in the world that are looking at climate well and have created research residency programs. I think that's one avenue in. So there's a Google program, we have a program, DeepMind have a program. I think large companies that have got structured research programs, I would say try it. This is a fairly complex domain. Try and get residencies where you can. And I think there's a few more collaborative platforms now that have come up. There was a very interesting research paper which I think was called Machine Learning and Climate Action, Jack.
Was it the Tackling Climate Change with Machine Learning paper?
Yeah, that's a good entry point, because that then breaks out all the climate problems by different domains: energy domain, waste disposal, agriculture. That's a good entry point to read for anyone to read, and just jump onto the forums as much as possible. Obviously, there's companies like Jack's company, my company, other firms that are opening up, just have open conversations. But I think the space is opening up for a lot more ML. There's a lot of interest in ML and climate all of a sudden in the last couple of years. Certainly wasn't there 5 or 6 years ago.
Thank you. Anything to add to that, Jack?
Yeah, so definitely agree. Go and check out that paper. But also, I suppose my one thing in the last 20 seconds is dive into the domain. So go and do internships at your local electricity grid system operator or other energy company. I think in many ways, the hardest bit to wrap your head around in these problems is the domain. These domains are enormously complicated, and there's just and a lot of it isn't really written down. You just need to go and spend as much time as you can with people in the domain and really soak up the challenges that they face.
Thank you. We're going to wrap up now and move to questions. There wasn't nearly enough time in this session to get into everything that we could have talked with Jack and Iggy about. So do join us for those. I wanted to bring Jack and Iggy here because they have done something concrete and real using machine learning to try and be impactful in this space. So I thank them very much for sharing what they're doing.
Thank you very much, Libby, Iggy, and Jack. That was an absolutely fascinating discussion. And as Libby said, they're going to be moving into the Q&A section at 3 o'clock, and it'll run until 3:30. So any questions that have already been submitted through Slido will get fed to Libby to put to Jack and Iggy. But of course, please do join the session and add any of your questions as well that you've not yet had the chance to ask. So that'll be kicking off at 3 o'clock. So do go and join that. And then later on this stage, we've actually got a break. The next session is not until 5 o'clock. That's going to be on making workplaces safer, tech to see us through to a vaccine. Really exciting things coming up later on this evening. Thank you very much. Hello, everyone. Welcome back to the cutting edge stage at CogX this afternoon and evening. The next session is going to be on making workplaces safer, tech to see us through to a vaccine. So thank you so much to everyone who has come to join us for this session. We've got two speakers for this one. First of all, Rob Glazer, CEO and founder at Real Networks, and joining him will be Eric Hess, Senior Director for Product Management of Safer Face Recognition Solutions at Real Networks. I'm going to hand it over to Rob. Do enjoy the session and join me in welcoming both Rob and Eric to the virtual stage.
Thank you, Gemma, and good morning to my friends and colleagues and audience in the States, and good afternoon to friends over in the UK and the rest of Europe. It is great to be with you. I had been hoping to be with you in London, as had many others at CogX, to go to the Berlin conference. Hopefully in 2021, we will be able to do that. But in the meantime, we are here to talk about an important and hopefully we'll find relevant topic, which is how do we make workplaces safer in this period before the vaccine? Now, I think I'm going to go to my slides, if I may, AJ. Beautiful. So, wanted to give you a little context. This is an exciting year for us because this is the 25th anniversary for Real Networks of our initial rollout of our first product, which was Real Audio, which is well known for having introduced streaming to the internet. And so that was 1995, which feels to me like the blink of an eye ago, but of course was actually 25 years ago. Since then, we've had a series of innovations. We came out with a Real Video to bring streaming into the mainstream in 1997. We were associated with the first music service, Rhapsody, that had music from all of the major music companies. If I roll the clock forward to the last 5 years, Real has become very focused on artificial intelligence through a series of products over the past 5 years, culminating in what we're going to be showing you today. The first product we had that used artificial intelligence in an interesting way was called Real Times, which automatically generated slideshows from people's personal video libraries and connections. Then we came out with Context, which used artificial intelligence to avoid spam and phishing and other things from text messages. Those products are in the market today and enjoying large audiences. Relevant to what we're discussing today, 2 years ago, we introduced our general purpose computer vision platform, which we call SAFER. And SAFER kind of stands for Secure Accurate Facial Recognition, but it really stands for SAFER, because our focus in bringing out SAFER was to think about how to make the world safer using this kind of technology and computer vision specifically. One point I'll make before we talk about today's topic is just a week or so ago, we introduced two new products that actually use SAFER in a consumer-facing way. One is called Real Player 2020, which introduces computer vision into our venerable Real Player. So you can actually use this product to find the faces of about 15,000 celebrities and public figures. And it's a database that is constantly growing and ultimately is going to be crowdsourced. And there's a version of that technology that works as a Chrome extension called Star Search that we also released at the same time. So our innovation is actually, if anything, accelerating during this terrible pandemic. Many people around the world on our team are doing great work, and I'm very proud of them and happy to share that work with you. Now on to SAFER, which is the topic of what we're going to demonstrate today. SAFER is a platform that as I said, we launched about 2 years ago. It is characteristic relative to other facial recognition solutions as being very fast, very small, and highly accuracy. The general entity that does testing for these systems in the United States, but it's really recognized globally, is the National Institute of Science and Technology, or NIST. And in NIST rankings of facial recognition algorithms, they do derbies 2 or 3 times a year. SAFER typically ranks in the top 10% in terms of recognition accuracy. And of those top 10%, it tends to be the smallest and the fastest of all those systems, which means that it can be embedded in devices, for instance, in cameras, and it means it can be run in a very cost-effective way from a computation cost standpoint. A second point that I'll make, and in these times, this point seems to be super important. We've put tremendous effort on having our system have as low bias as possible. And that has a lot to do with our algorithms. It has a lot to do with our training data. So NIST actually does an analysis of how these systems do in recognizing different cohorts. They have their own definition of who are in cohorts, typically ethnic cohorts and racial cohorts. And by their measures, we have one of the lowest biases of any system, which is to say our accuracy is uniform across different cohorts and different subsets. And that's very important to us because any of these systems have very significant social and policy implications. So we want to make sure that our system is accurate no matter how it's used. A related point is many facial recognition systems choose to characterize people in a number of different ways. We do some of the ones that we think are objectively based, like gender and age, which are generally recognizable phenomena. We also will do sentiment analysis, which is typically more useful for aggregate basis. But we do not, and we never will, if I have anything to do with it, implement ethnic classification in our software. For many, many reasons, longer topic than today, other than to say we're dealing with times right now where systemic bias is one of the topics that's at the fore after the tragic murder of George Floyd in particular, as well as other things that have happened. We have built into our system no ability to characterize ethnicities because we think that that is a tool that tends to be misused and mischaracterized. In general, we have focused safer on positive use cases. Our first commercial deployments were in schools, where we helped schoolyards make sure that the only people in the schoolyards were parents and staff members and people that were supposed to be there and not people that aren't supposed to be in schoolyards. And that was something that in a place like Seattle, which is where we launched that product, got very positive feedback from hundreds of parents associated with the schools that we initially deployed it at. So our focus continues to be how we can use facial recognition technology to make the world better. So here we are in 2020 in the middle of a pandemic, and we have, on a worldwide basis, over 400,000 people have lost their lives. Tragically, over 6 million people have been tested positively for the infection with the virus. Certainly many, many others have it without having been tested positively. Around the world, after 2.5, 3 months of social distancing in an extreme way and shelter-in-place, stay-at-home policies and rules, societies around the world are asking, how do we safely reopen society before there's a vaccine? Vaccine efforts are incredibly important, not my field of expertise. Hopefully others in CogX are talking about how to use AI to accelerate those kinds of treatments and ultimately vaccines. But with regard to challenges today, there's several things that doctors and epidemiologists and scientists recommend to lower the risk of infection. One is limiting occupancy in physical spaces. One is encouraging social distancing. One is encouraging mask wearing and even auditing mask wearing in locations where the masks are a required part of the location. AI and computer vision can be used to address all of these topics, and we think there's a role for it to do that, and we think that there will be interesting market solutions that do that in the weeks and months ahead. What we are demonstrating today publicly for the first time is our effort related to mask wearing. And there are two use cases in mask wearing that we want to focus on. One is basically a system that allows the person who is supposed to be wearing a mask to know whether they're wearing a mask or not. And if they're not wearing a mask, it can be used to gently ask them, remind them the rules or to wear a mask. If they, for some reason, don't wear a mask, it can be used to alert somebody in question, that the authority, that they're not wearing a mask. And maybe the security guy at the grocery store wants to ask them gently, hey, are you able to wear a mask? If not, here, I'll loan you one, or I'll give you one. That's one use case that we think is important. A second use case is actually recognizing a person while they're wearing a mask. We have a very, very accurate facial recognition system, as Eric will talk about in a minute and I'll follow up on. But recognizing people while they're wearing a mask is obviously a challenge because your algorithm doesn't have half the information that it would otherwise have because the bottom half of the face is occluded. So how do we actually design and redesign our algorithms and train our models to be better at this? Well, we have both of those well under development and starting to come to market. And I'm now delighted to do a demonstration of that. To make that demonstration, let me reintroduce you to Eric Hess, who's our Senior Director of Product Management, focusing specifically, among other things, on this opportunity and use case, and been working with our R&D teams around the world to implement something we think is very significant. So with that, let me pass it to Eric to do a demonstration.
Good day, all. I'm excited to share with you some of the new developments in the safer facial recognition platform from Real Networks. We believe this work will help make workplaces safer until a vaccine for COVID-19 is available. What you're watching now is Safer performing real-time face recognition against live video. Until recently, our primary focus has been to continue to improve the accuracy of our algorithms, recognizing additional kinds of objects, making Safer smaller and faster, and enabling it to be integrated into a wide variety of products and platforms today. A new kind of object that has become very important is the face mask, as Rob has already alluded to. For many people and many workplaces, wearing a face mask is now part of everyday life. And indeed, it's a necessity that will probably remain with us for some time. So we've trained our AI models to understand masks and how they interact with faces so that we can deliver new tools for society today. This engineering effort now enables Safer to recognize when a face is occluded and to determine what type of object is causing the occlusion. I'll give a couple of demonstrations. Whether it's a basic cell phone that is occluding some portion of the face, whether it is clothing choices that somebody may have, or as somebody is coming into work or walking through a store, if they happen to be enjoying a beverage or any of the things we do every single day. We are able to recognize when these occlusions are blocking a portion of the biometric data within the face. And that enables us to do even better with a job of recognizing individuals. As you can see, Safer has been able to recognize when views of the face have been blocked. We had this icon up here indicating that an occlusion is blocking some portion of the face. What I'd like to bring your attention to next is the addition of an additional emoticon indicating that Safer has recognized the object that is blocking my face as having the characteristics of a face mask or an equivalent kind of PPE, personal protective equipment. So let me show you a few masks. First off, I have a standard surgical style facial mask. You'll notice the additional emoticon above my face indicates that first, we recognize there's an occlusion, but that we've also recognized the occlusion is due to a face mask. The value of this innovation cannot be understated in a world where masks are now not only common, but in some locations are mandated for public reasons. Let me show you a variety of other masks. Whether it be designer masks, personal preferences, etc., we're able to recognize the wide variety of masks that people may wear today. Notice that Safer can even recognize when a face mask is not being worn in a manner to cover both the nose and mouth. So again, I'll demonstrate some additional masks. We have the emoticon indicating the mask is present. But if I am not wearing the mask properly, we see that it is recognized as not being present. I'll even show another one. Face masks take all forms. As we can see here, a traditional balaclava type of scenario. Again, if the face mask is not being worn properly, covering both the nose and the mouth, then it does not show. We're still training our Safer AI model to understand lots of different kinds of masks. Our goal is to be able to recognize every kind of popular mask, whether they be handmade or purchased. We see many uses for mask detection in stores, in workplaces, even in schools. Safer with mask detection can be integrated with other systems. So if someone isn't wearing a mask, they might either hear a recorded reminder played over a speaker, perhaps as they enter a grocery store or a place of business, or a staff member might be notified. Safer can also be integrated with access control systems, unlocking the door when a person is recognized and properly wearing their face mask. This is the second use case I want to show you, how Safer has been enhanced to recognize faces even when people are wearing masks. As you've noted, throughout the demonstration, Safer has continued to identify me by name underneath the face detection. And I'll share with you, I am running this on a database of 7,000 individuals in the background on my demonstration laptop. Safer has very high accuracy for this use case, typically over 99% accurate, with very few false positives. But you could imagine that someone wearing a mask makes the job of facial recognition much harder. In fact, I'm sure many of you have tried to unlock your iPhones while wearing your mask today, only to discover that it doesn't recognize you when you're wearing that mask. So I'm pleased to demonstrate that we've made great strides integrating our new mask detection capability with Safer's face recognition algorithms. We estimate that we have achieved over 96% accuracy, meaning that 19 out of 20 times we'll recognize someone without asking them to remove their mask at all. This enhances personal as well as office safety by encouraging people to wear masks at all times. We're continuing to train our AI models to make even more accurate recognition of faces. And we're looking forward to releasing new algorithms with these improvements and more to our customers in the near future. So from everybody within the Safer team and Real Networks worldwide, we're very proud to bring you these new tools to help bring us into the future until a vaccine for COVID-19 is available. Thank you.
Thanks, Eric. So just to put some of the data Eric gave you in context, so the data we have, and this is based on our own tests, is that for the kind of use case we've described, our accuracy in terms of true positives, when we've tuned the algorithm to have false positives, is 99.4+% accurate when there's no face, just regular recognition. And that's a case where you've got less than 0.05% of false positive rate, so a very low positive rate. With the mask as currently implemented, you can tune it for the false positive rate. That's still at a very low false positive rate of less than 0.5%. And with that tuning, we get over 96% mask accuracy. And of course, we can tune it up and down, or customers can. So if you want absolutely no false positives, we can get to even lower false positive rates, like we've shown in the regular recognition case, with slightly lower true positive rates. So that's where we are today. We're very pleased. Frankly, this quality has exceeded what I thought we'd be able to get to in about 3 months in terms of recognition accuracy when people are wearing masks. And there's many, many positive use cases for that we expect to deploy with customers in the weeks and months ahead. So in closing, we're at a very tricky time for the world right now. People are very, very interested in returning to some kind of normal. People are feeling, from an economic standpoint, from a social standpoint, wanting to engage more in the world. Science has learned a fair amount, although we're still learning about the infection characteristics of COVID-19 infection of the new coronavirus, and learning what are things we can do that significantly decrease the risks of infection. Face masks are clearly at the center of that, from the standpoint of primarily, as I understand it, from the standpoint of transmitting infection, to a secondary degree from the standpoint of lowering the risk of receiving infection. So because of that factor, the face mask that you yourself wear doesn't protect you nearly as much as if everyone around you is wearing a face mask. So in that context, having a system that makes it easy for people to be encouraged to wear face masks, reminds them that it's important to wear face masks where they're in a place where that's the policy, and where necessary, lets somebody responsible for the space know that there's people there that are not wearing face masks in areas where they're supposed to. That kind of solution actually, we think, can play a very significant role in helping society reopen in a safer way. More generally, stepping back, we are very bullish on how AI can be helpful in a number of ways. I identified some of the other use cases that are also we and others are working on developing. And just more fundamentally, we are believers, and I'm personally a believer, that this technology truly can help make the world a safer place during this period where we still have a pandemic that is having significant, terrible impact on people around the world. And as we move towards a world that is more opened up, where we don't want to see the rates of infection, illness, and death go up. So with that, I think we are done a little bit early this morning. If anybody watching this has any questions before we go into the Q&A, I think we have a little time for that. Otherwise, we will join the folks over at CogX in the Q&A session that is formally set up after this. But as moderators, I think if we do have a few extra minutes, if anybody has any questions prior to going to the formal Q&A session.
Great.
So I guess I have a question for you, Eric, if we're waiting for audience questions. How long has it taken us to develop this capability? When did we really start training our models for masks? When did this start in terms of an earnest effort to build the capabilities we're showing today?
Absolutely. Well, it was in March that we sent our first request to employees internally to send us some examples of masks that they may be wearing. Very late March, early April. And so it's been a very, very rapid development that the team has undertaken. And it's only through the advances of AI and deep learning and the great effort and long hours through our engineering teams that we've been able to bring this to market so far.
Great. Well, I know that we have a formal Q&A session set up next, so we'll probably get questions from audience members. So I, of course, have many more questions to ask you, Eric, but I'm not going to turn this into a project review. I want to thank everyone for joining us today, and those of you that are going to be joining us in the Q&A, we look forward to seeing you there in a few minutes.
Thank you, Rob. That was really absolutely awesome. I really love the idea that there's something that could get us back to a new normal. I found that technology is clearly going to be the way out of so much of the coronavirus crisis, and that was just a masterclass in ways that could happen. As Rob would have just said to those of you watching, if you have questions for him, please go to the CogX app and you will be able to get those answered. I want to race over there myself, but I'll be staying here with you on the cutting edge stage, and I look forward to Hello, and thank you for joining us here on the Cutting Edge stage. What a day we've had. I've been blown away by some of the technology that we've seen that's coming in the next 5 to 10 years. I hope you've been tweeting along with us at the hashtag CogX2020, and you have been going on the CogX app and asking your questions. Next up, we have the fantastic Gemma Milne, the author of the book Smoke and Mirrors, but you might better know her as your MC that you've had for the day. We couldn't let her go without asking a few questions about her book. And who better to do that than the man himself, Matt Clifford, the CEO and co-founder of Entrepreneur First, who is well known for being able to spot between the smoke and the mirrors. I will leave them to it and come back at the end. Thank you all so much for tuning in. Over to you, Matt.
Hello and welcome. My name is Matt Clifford. In my day job, I am co-founder and CEO of Entrepreneur First, but I'm very excited to be here today to talk to Gemma Milne about her book, Smoke and Mirrors. Gemma is a science and technology writer and a participant in lots of the innovation ecosystem through her work with VCs, governments, and many other organizations. So I'm delighted to have Gemma here and delighted to talk about her book, Smoke and Mirrors.
Thanks very much, Matt. Appreciate the invite and returning back onto the stage in a different way than now.
Well, it's really exciting that we get to talk about Smoke and Mirrors because I was very lucky, privileged to read this book before it was published, thanks to you, and have a chance to provide a blurb. So I'm a huge fan of the book and its argument. I actually, because I know the book well, I have lots of very detailed questions that I hope will actually be fascinating for the audience. But assuming that not every single viewer may have read the book, do you want to maybe just open by telling us what is Smoke and Mirrors? What is it about?
Sure. Well, I mean, it started off as a book to kind of quell my frustration around how we talk about science and technology and kind of, for lack of a better word, bust the hype on many different areas. So, you know, there's 9 chapters in the book and it covers everything from cancer therapeutics to food technologies, space technologies, quantum computing, AI. So all kind of deep tech. And I wanted to basically say, here are the overarching narratives that you keep hearing about these technologies, and this is why it's wrong. But as I kind of researched the book a little bit more, I started to really think a lot more deeply about what hype actually is and realize that it's not just this frustrating thing that those of us in the industry get annoyed at, but in fact, it's this quite important tool for, you know, simplifying complex ideas, getting people on board, being heard. And so instead, I wanted to write the book that was more a empowerment tool for people to be able to understand the role that hype plays, understand their role in terms of, I guess, managing, taking in, possibly spreading problematic hype, and basically be a bit of a manifesto for critical thinking. Basically say the future of science and tech kind of, I guess, relies on us all being a bit more responsible about how we critically think around narratives in science and tech.
I think one of the things I really love about the book is it's extremely balanced. This is not one of those books that sort of comes in with an agenda and sort of whacks you over the head with it. I think we see in the book sort of the hype as a double-edged sword, and you know, both its power and to do sort of both good and ill for tech. I sort of, one of the things I felt as I read it was that there's quite a lot for an entrepreneur, for example, to take from this book, both as sort of like hype as a tool for them, but also as a sort of potential pitfall. I'd love to hear your thoughts on that. Like, what do you think that entrepreneurs can take away from Smoke and Mirrors?
Well, I mean, the big question that I kind of keep getting from entrepreneurs, particularly deep tech entrepreneurs who, you know, a lot of them are coming from science labs where overhyping what you're doing is really not in the DNA of scientists at all. If anything, they're kind of underhyping what they're doing most of the time and sort of being sometimes a little bit too detailed and losing the excitement that, you know, they deserve, frankly, in terms of what they're doing. So I suppose the question I always try and answer is, how do you responsibly hype? You know, we all have to accept that hype is a tool that is required. There is a bit of a game that needs to be played in terms of getting your science and technology to market. And so when it's about, you know, how do you move things forward in a way that serves the mission of getting out there without doing anything detrimental? It's really about responsible hype. So the two kind of big lessons that I have around there for entrepreneurs, one of them is around making sure that you're very, very clear on what your vision is versus reality. So it's absolutely fine to talk about vision. Actually, it's key to talk about vision. I mean, you'll know that, Emma, as a VC, you're looking for people that are able to articulate vision. But at the same time, it's about being very, very clear about your current state and what the sort of time scale of that vision is, as opposed to kind of declaring that this is something that's either near term or being so kind of vague that assumptions are made and you don't correct the record. So that's the first thing. And the second thing is all around communicating systems more so than problem solution. And you'll know this, I mean, particularly with demos, quick demos, you only have 5 minutes to tell your story. There's this kind of standard storyline that entrepreneurs are encouraged to take, which is, you know, what's the problem? You know, to give us a personal story of someone that has this problem, talk through why no one solved it yet, give us the solution, and then ask for the money you need in order to make it reality. And yeah, exactly right. And so what I think in terms of responsible hyping is actually, how do you communicate a system story as opposed to kind of siloed, linear problem solution story? And particularly in deep tech, I think it is a little bit irresponsible to only talk about this this linear kind of blinkered route, because you're not taking into account the effects that your technology might have. And there's nothing wrong with saying, oh, if we solve this problem, it might cause X, Y, and Z. But without putting that forward, you're essentially reinforcing these narratives, which are sometimes not 100% kosher. And again, just a little bit, it's almost like relying a little bit on the vagueness for your own benefit as opposed to being fully truthful. So those are the things that I kind of try to advocate.
People watching who might not have read the book, can you give an example of sort of maybe a technology where that sort of systems view hasn't been presented and that's sort of had a negative impact?
I think, I mean, if you take some things in the food sector, that's one of the ones that I tend to talk about quite a lot, where the food industry is extremely interconnected. And I don't think that it's fair to talk about any new innovation that touches any part of that entire system from farm to fork, as they say, without presenting the kind of ripple effect of what that particular intervention is going to have. So for instance, if you're talking about, I don't know, a facial recognition app for dairy farmers, and you only talk about it from the perspective of, you know, health of cows and how that might impact you know, the amount of time a farmer has, and then therefore how much they can get done in a day, and so on and so forth. It's kind of not, I don't think it's good faith to talk about that without, you know, expressing what is the role of dairy farming in the broader context of agriculture, both in positive ways and negative ways. And those are harder stories to tell, and I appreciate that. And entrepreneurs, you can't solve all the problems in one go, and that's not the point. But I do think in terms of responsible hyping, it is about having that clarity, especially nowadays when people are a lot more expecting of nuance, right? When you say you're going to try and save the world, most people are like, yeah, but I mean, you can't actually save the world. So what are you really doing, you know?
Yeah. I think one of the things that I was really struck by as I read the book was the interaction of hype with this idea that's become very prominent in how we talk about founders, which is like the need for authenticity, and almost sort of authenticity as an antidote to some of the negative aspects of hype. I wonder if you had any thoughts on that. You know, how can you sort of be the person you want to be the founder you want to be, and yet interact in a world where hype is to some extent expected, demanded, even rewarded?
Yeah, I mean, in some sense, I'm like, yeah, it's a difficult thing because there's a game to play. But at the same time, I don't know whether it's just my like Scottish bluntness, but I'm like, it's not that difficult to be open and upfront and honest about the reality of what you're doing. And I believe that probably you'll be more respected as a business person, but also as an individual and a representative of other people, if you are able to express your role within broader society, as opposed to kind of coming across as this blinkered, we only kind of look at this one thing. I mean, in terms of authenticity, there's an argument to be made as well that if you're not thinking about and conscious of the system in which your business exists and talking about it normally, I'd kind of argue you're probably not the best person to be building something in a complex industry, particularly if it's in deep tech, where whatever you're working on is going to impact energy systems or food systems or health systems, things that are super complex, have many different stakeholders, are global. So if you're not talking about those systems already, I would be slightly suspect. And, you know, if it's authentic for you to not talk about that, I don't think it's going to count in your favor. And as I say, I do think that there's more hunger from good, whether it's investors, government funders, you know, consumers. There's a hunger for nuance and a hunger for what actually is just honesty about where you sit in the world. Do you know what I mean?
Yeah. Now, one of the things I love about the book, which I have to say is sadly all too rare in a lot of sort of tech-focused books, is really grounded in the history of the 9 technologies that you talk about. And I hope it was all right. I wanted to dive into one of them, partly because I was just extremely ignorant of it before I read your book, and I learned a lot, which is nuclear fusion. So I think like there's a lot to learn, I think, about the present and future of AI from looking at the history of fusion. I'm going to ask you a couple of questions about that. But before I dive totally down that rabbit hole, could you maybe just give a sort of minute overview for the audience of like, what is nuclear fusion and why does it matter?
Sure. Yeah, this is the chapter everyone's like, I was really surprised that you put a nuclear fusion chapter in. And I go, that is precisely why I put that chapter in, because I think it's crazy that more of us are not talking about fusion, frankly. It's a technology which, well, it's from a science perspective, it's what happens in the sun. So it's how the sun, basically, the energy that comes from the sun is as a result of fusion. So if you talk about nuclear power stations that exist right now, they use a process called fission, fission, which is when you're breaking apart the molecules, whereas with fusion, you are fusing. And basically what physicists have been trying to do for years is work out how to recreate what happens in the sun and then create a reactor that can then utilize that process to provide energy. And one of the kind of big arguments for it is that if you can get it right, if you can create the spark, if you will, that starts the reaction, you should be able to put less energy in than you get out. And so it's obviously a brilliant form of energy if you can not only manage to recreate the process, but then also scale up in terms of creating reactors and factories and plugging it into the grid in an effective way. And this has been, as I say, something that's been talked about and researched for the last sort of 70 years, and it's gone through a lot of disappointment, particularly fueled by like Cold War narratives, a lot of countries wanting to hype up how good they are at fusion and say that they're creating the future of energy and whatnot, and then it hasn't happened, and it's created a sort of, I guess, a public sentiment that starts to believe that it's not a real thing, or that it's really, really far away and it's never going to happen.
You talked in the book several times about the sort of like nuclear fusion is always 50 years away.
Yes, exactly. And it's funny, I was interviewed on BBC Radio 3 at the start of this year, and about, we were talking about other stuff, and fusion just kind of happened to come into the conversation, and the host said, oh yeah, it's 50 years away. And I was like, no, this is what I mean. It just keeps getting repeated, this same idea. And we've been saying 50 years away since the 1950s. So, what I mean? It just kind of keeps shifting. And the thing that I say in the book is that fusion is kind of it suffers from of the curse of the long-term joke, and the lack of positive sentiment as a result of this repeated narrative means that people don't know about it, don't support it. If you had a politician being like, we're going to put a whole load of money into fusion, most people would be like, don't we already have nuclear? And get confused between the two. Some people think it's pseudoscience because it gets confused with cold fusion, which is pseudoscience. So there's lots of issues around fusion just not really getting the attention. The reality is the biggest science experiment on the planet, bigger than CERN, right now in the south of France, is a huge fusion experiment that's got collaboration of countries all over the world, and nobody knows about it. And I think it's crazy.
Yeah, you describe yourself in the book as a fusion optimist, and this experiment, is it pronounced ITER or ITER?
ITER, yeah.
Yeah, so ITER's, I mean, maybe you could just give a quick overview of ITER, because it's actually one of the most exciting things I've read about this year. But I confess I'd never heard of it. Right,
and this is the thing: people who are, you're very, very involved with the exponential tech world, and exactly, so few people know about what's going on with fusion. So ITER is essentially the government effort, the science experiment. So they're trying to prove that it can be done. They're not necessarily right now at the stage of being able to create reactors that can be deployed all over the world, but they're at the point of being able to prove that this is something experimentally that can be achieved. So far we've not been able to prove that we can put energy in and get more out on the other end. And in 2025, ITER is turning on, shall we say, and it's quite a big moment. Although some people argue it's a huge moment, other people say it's not. But the reason a lot of people say it's a big moment is because I'm pretty sure I'd be very, very surprised if you don't start hearing a lot more about fusion over the next couple of years in the build up to this switch on, because it's exciting. And once ITER, their comms department start telling the world's media, hey, we're going to be, same as CERN did with the Higgs boson. Hey, come on, we're going to be demonstrating fusion, the future of energy, right? They're going to be, and if they turn it on and it doesn't do what they said it would do, because it's a science experiment at the end of the day, I worry that sentiment again will plummet. It'll be very easy to criticize, even though it's an experiment and even though it's not necessarily meaning that all our energy is going to be cheap tomorrow once it's turned on. The other side of it is there's a lot of critics of ITER, particularly in the sort of startup and private sector, where they say governments have kind of put all their research eggs in one basket. They've chosen a particular type of fusion that they focused on, called the tokamak. And also, there's the usual arguments around government bureaucracy versus the supposed faster methods of the private sector. But it means that you are starting to see a lot of startups pop up that are wanting to create their own methods of fusion. And indeed, we have a few even in Oxford. Whoa, it's very bright. Sorry, out my window. I probably look like an alien right now. Sorry about that. But yeah, so that's basically kind of what's happening with ITER. And as I say, I'd be very surprised if it's not something that becomes a bit more regular in at least the tech news anyway, on Wired and places like that over the next couple of years.
That's great, because there were three sort of themes that I wanted to try and draw out from fusion, which I think have like very broad applicability across technologies. And you've already touched on two of them, which I just would love to push you on a little bit. So one is like, something we've heard a lot about in AI over the last, since AI became big again in the last decade, is the danger of an AI winter, the sort of hype cycle disappears, and rather than that just being a sort of drop off in growth, it's actually a net negative event where cash and talent flow out of the sector. And in a way, the history of fusion seems to bear that out as well. I wonder, when you kind of looked across the 9 technology areas that you do look at, is this idea of like a winter effect where hype can actually produce like a net negative effect? Is that quite common?
I mean, it's in terms of being common, it's certainly AI, I think, has the most evidence and research looking specifically into what it means for there to be a winter. In the quantum computing chapter, that's part of my argument, is that I believe there could possibly be an upcoming quantum computing winter, because of there's been you've probably seen there's been tons of excitement around quantum. Actually, I think you guys have a few.
We have several quantum computing investments, yeah.
Precisely. So there's a lot going on in this space. what that means is there's also a lot of expectations, sometimes wrong expectation around the speed at which particularly return is going to be gotten through these companies, and particularly with investors that have these sort of shorter times to exit, whether it's 5 years before they get some kind of return or whatever. With quantum computing, this is not something that's going to happen overnight, but it's like required the hype in order to get the investment. It's been this sort of, well, we really need people excited about this, so we're going to tell them that quantum computing is the future, but oh crap, now we need to quickly do stuff to make sure we don't disappoint people and don't have the investors pull out because they're disappointed, which, as you said, has happened with AI. With fusion, I don't see it as much of a winter as such, because there's not as much investment.
Never been a summer.
Yes, exactly. I mean, we've had government focus and whatnot to an extent, but it's more about trying to encourage investors in the first place to even look at this. I mean, investors I was interviewing were normally angels. It's not even, we're struggling to get kind of, or high net worths. It's less kind of it's the kind of moonshotty sort of investors more so than the so-called kind of more rational investors. It's still a little bit early for that. But yeah, quantum computing one is one that I'm kind of keeping an eye on in terms of winter at the moment.
You referenced there sort of the role of government in this, and actually, in particular, when you talk about fusion, you just mentioned there's almost like this tension between government approaches and private approaches. Again, sort of interested in whether you saw that as a theme in general around some of these very deep technologies that go through hype cycles. Did you, in writing the book, did you sort of reach any conclusions on what you think is the proper role of government in sort of pushing these things forward?
I mean, we've read a lot over the last couple of years, particularly from people like Mariana Mazzucato, about the huge role that government actually has, and in some sense, I think we sometimes don't really give it as much credit in deep tech. I mean, especially when you look at pharma, when you look at that kind of early amount of investment, those kind of very risky explorations of things that ultimately sometimes turn into something that could be commercializable. I'm not so sure about whether or not I came to any huge coming to God moments around the role of government. I do think, though, that some of the narratives around government being bureaucratic and slow and business being innovative and fast can sometimes be a little bit damaging. However, in the fusion chapter, that is kind of what that is what a lot of people are saying, and there's arguably it's justified to some degree. So I don't know. I mean, for me, I think it's more about how do we expose, not in something terrible's happening, but how do we talk more about what tech transfer actually looks like? So few people understand that process. And I think when you start to understand from the conception stage, from the let's get a grant stage, all the way through to whether it's the exit or the go-to-market of the thing, whatever that might be, there's many different roles within that, both from a funding perspective, but also from like a responsibility perspective, from a choice of how you, I don't know which business model you choose or how you apply technology. And government and private play big roles. And I think sometimes they're kind of pointing at each other going, that's your fault, that's your fault, that's your fault. When realistically, it's actually, it's a process that relies on each other quite a lot more. So for me, it's more about how do we get everyone within the, within the ecosystem, as you mentioned at the start, in terms of we're both involved with, understanding that it's not just a case of some coders building some software and then a company is built when it's deep tech. It's got a much longer and more complex and interesting, fascinating process that is tech transfer.
Well, I think with that's probably a good and thought-provoking note on which to wrap up this part of the session. There is a Q&A, so don't go anywhere. You'll have a chance to ask Gemma questions, but thanks for joining us, and thank you so much, Gemma. Smoke and Mirrors, fantastic book, highly recommend to everyone.
Gosh, I am all about responsible hype. As I was listening, I thought to myself, am Am I part of the problem? That was really fantastic, Gemma and Matt. Thank you very much. And those of you who have some questions for Gemma, head over to the Cognition X app and you can ask those there. For those of you who are staying here, please take a little bit of a break, sit back, and we will be back in half an hour with a session on quantum. So if what Gemma was saying to you about quantum got you excited, we have some of the world's experts at 6:30. So I will see you then. Did I get that right? 6:30. I freaking hope so. Hello, and welcome back to the Cutting Edge stage. We have had an incredible day looking at technologies that we might be able to see in the next 5 to 10 years and how they'll impact our lives. I hope you're tweeting along with the hashtag CogX 2020 and that you'll enjoy this next session and store up your questions, because this one is about quantum computers. When you Google quantum computers, the first thing that comes up is, do they really exist? Which tickled me and made me realize that we must have a session at CogX talking about quantum computers, what they are today and what they could be in the future. So I'm really thrilled to introduce Nick Fishwick, who is going to talk us through those challenges with his illustrious panel. If you have access to the CogX app, you can stay afterwards to ask them questions. If not, ask your questions now in the app, and they will come to them later. Thank you so much. I will see you afterwards. Thank you.
Thank you, Tabitha. My name is Nick Fishwick. As Tabitha just told everybody, my background is in national security and intelligence with the British government. And I retired a few years ago. And now one of my roles is as a non-executive director for a quantum computing company, CQC. And I'm very pleased that I've got 4 people in the panel today who really know about quantum computing. Order. So first of all, I have Anthony Annunziata. Anthony is director of the IBM Quantum Network, and what he's about is about creating a new ecosystem from scratch. That's Anthony's mission in life. Secondly, I'd like to introduce Andrei Koenig. Andrei is the chairman of OneTech. He's an investor in quantum startups. So he's about building quantum brained initiatives right from the get-go and right the way through. Thirdly, I'd like to introduce Denise Rufter. Denise is the Chief Business Officer of Cambridge Quantum Computing. And finally, Tony Utley, who is the president of Quantum Solutions, Honeywell. I'm delighted to have Tony with us as well. So I'm going to ask each of our participants a question, and they will answer the question, and we can take the discussion from there. And any questions that anybody wants to put from those who are following this discussion, please send them to me, and I'll try and feed them in if I can. So I started this session alphabetically. I'm going to continue it alphabetically. So it's a kind of a question for Anthony, which is about quantum. First of all, why is quantum important? Secondly, how do you get started in quantum? What do you need to get involved in quantum, to use quantum? And why is now the right time to do that?
Thanks, Nick. Let me take your first question. Why quantum computing? What does it offer? Quantum computing is really the first new approach to computing in decades, arguably even longer than that. Quantum computing at its core utilizes the laws of quantum mechanics, the revolution in science of the 20th century, to create the possibility of solving very hard problems. That is, solving problems that we have never been able to truly solve before. It doesn't matter how advanced our classical computing based on ones and zeros gets, it really can't solve certain classes of problems. And quantum promises to do so. That's why it's so exciting. Now, how do you get started is a very interesting question that has a much better answer today than even a few years ago. Because at the start of the session, as Tabitha reminded us, it's still a question in some people's minds about whether quantum computers even exist. I can definitively tell you they do exist, and you can start using one in about 30 seconds. Now that is a significant breakthrough, and that's only been true in the last about 4 years. So the first step to learning about quantum computing and getting started is to start to access the resources that have just come available in those last few years. Namely, being able to use real quantum systems online, on the cloud, and also a plethora of informational content, whether it comes in the form of YouTube videos, online tutorials, books, and other really a very easy way to get started now, and it really wasn't true even just a few years ago.
And on the question, why now, Anthony? Why would you say now is the time to look at this?
It's another good one. So think about quantum the way I started. Quantum can potentially solve problems that can't be solved any other way, really offering like breakthroughs in our ability to solve hard challenges in business and science and society. However, the flip side of that is that quantum is still pretty hard. Even though it's easy to get started, it's hard to master. It's hard to figure out whether you're an individual developer or an organization, how it fits into your day-to-day work, how it fits into your business strategy. So while it's extremely promising, it's also extremely challenging. So it's not too early to get started, even though the technology has a ways to go to come to full commercial fruition. The time to start now is now, because the potential is great, but the learning curve is a bit steep as well.
Cool. Okay, that's very interesting. Thanks. Well, I'm going to go on to a different question, and this time I'm going to turn to Tony Utley. So I'm breaking alphabetical order, and I think Denise might have some views on this issue as well. So I'll probably bring Denise in after we've heard from Tony. I guess it's about timescales. Some people say quantum, it's always going to be ready in 10 years, and then 2 years later, it's still going to be ready in 10 years. And we've just heard from Anthony that actually, in some ways, it's ready now. So I guess I'd like to hear from Tony about timescales. Where are we in quantum, and where are we not?
That's a great question. So I've heard a phrase where quantum computing has been 10 years away for about the last 40 years. And the way we typically talk about it, or at least the way I talk about it, is in 3 eras. The first era is this emergent era. And it's an important one because it goes from quantum computers didn't exist and now they exist. So that is just a step change that allows people to be able to start actually operating on real quantum hardware. They can put in algorithms that get results. They can start to see what works, what doesn't work, and you can start to tune systems to continue to make progress. There's a third era, so you can tell I'm skipping one, and that third era is this classically impossible. It's this time where no matter if you use classical resources for the age of the universe, you could not solve the problem that you can solve with a quantum computer. And that still has a ways to go. There is there may be a decade to get to some of those really, really challenging things. But there's a middle era. And the middle era is what I call classically impractical, and others call it a quantum advantage. And it's where you can use co-processing of quantum resources alongside of classical resources to carve out problems where this piece of the problem can be done much more efficiently by using quantum resources. Just like you would do with a graphical processor unit, a GPU, you're going to have a QPU. And this era is starting right now. This is where we can look at problem sets that affect humankind and shrink those problems to the size quantum computers can deal with today, and then scale them rapidly as the capabilities of these quantum computers scale.
Great. Okay, that's very clear. And I'm going to ask Denise the same question. I guess you might answer it from a slightly different perspective.
Yeah, so thank you, Nick. At Cambridge Quantum Computing, we're a software company. So we work with existing quantum computers, both the IBM quantum computers and the Honeywell quantum computers, as well as others. And we develop software solutions for quantum computing. Right now, quantum computing is progressing actually at a very fast rate. And we're excited about the possibilities to solve real world problems, I would say, over the next year or two. What I did want to do is earlier, we have a question. Earlier, there was a question about how someone can get started on a quantum computer. And so I wanted to hand over to Anthony to talk about that for a second. But I just did want to say that quantum computing is here and everybody should be thinking about it now. And incorporating it into their overall company strategy. But Anthony, why don't you talk about how to get started?
Sure, it's kind of an easy answer, actually. You can simply go to ibm.com/quantum computing and start there if you'd like. We have been offering free access to quantum computers on the cloud for about 4 years now, and we've gotten hundreds of thousands of users and billions of executions on those systems, which has just been great to see, that level of growth. Now, I think others are starting to offer that as well. I can defer to others on the panel if they have other ways to get started, but that's the one I know and love.
Okay, Tony, did you want to add a bit to that as well, coming from Honeywell?
Yeah, but I'll abstract it maybe a little bit, which is how do you get started if you're an individual, and how do you get started if you're in a company and you're thinking about this? It starts with education. This is programming a quantum computer is very different from programming a classical computer, and unfortunately, instead of it being thousands or tens of thousands of developers out there, there are small hundreds of quantum algorithm developers out there. And so learning how you actually go do that is something that's important for individuals. And this is going to be important for a decade. So if you're out there thinking about what career do I want to have, thinking about doing, learning how to program quantum computers, learning quantum algorithm development, that's a pretty cool place to start. If you're a company, one of the things that I hear all the time is, okay, so you have quantum computers, you can do some of these early actions with them, but when is it going to solve my problem? And that's a great question, but it goes alongside, how long does it take to insert a technology like this into your business infrastructure? There are a lot of companies, Honeywell is one of them, where the development cycle for your products might be anywhere from 18 months to 10 years if you're developing a new molecule. And in either of those timescales, you have to plan now if you're going to insert quantum computing into your processes. So sitting on the sidelines may say, well, I can wait till it really evolves and shapes itself. That may put you that length of time behind certainly all the forward-leaning companies and partners that I'm sure Anthony and his folks are talking to, as well as our team.
Great. Okay. Well, I think that's a good time to bring in Andre from the perspective of the same kind of issue, really. And I think a lot of people will be interested in this point of companies making use of quantum. And it's a question, the question is, are companies now pursuing quantum, Andre, as a strategic priority? And how should they be doing this?
They absolutely are. And my perspective, unlike my fellow panelists who build quantum hardware and software, is the one of a business executive, investor, and entrepreneur in this space. And companies are doing quantum today in many different forms and shapes. Anthony at IBM, Tony at Honeywell, and Denise, who is at the forefront on the software side of business development every day, all have clients and partners that use the current NISQ era machines, which are these machines that work today but still have some issues that we need to solve around them before they really can deliver results. Are available in the cloud, are available for certain other vendors on premise, and companies are working on them. They might not today get ultimate business results in terms of solving a specific use case just yet that they couldn't solve on a supercomputer or in another way, but they are getting what Tony and Honeywell calls this quantum practical, a real benefit in a learning curve and an experience in making fast progress along this implementation and execution part in quantum computing. There are also many other applications within quantum technologies, quantum information science, such as quantum key distribution, quantum sensing, quantum communications, that all have very real applications around encryption, security, the quantum internet, and many other things that are being deployed and developed today. There's a question from the public, Thomas, I believe, about a roadmap from these current NISC-era machines to, a real supreme quantum computer or a universal quantum computer. And IBM, Honeywell have well-guarded but very specific and detailed roadmaps to not only get from the machines that they have today to continuously iterate and improve them along a number of metrics. There are also vendors that entirely focus on building these machines that might ultimately deliver thousands, if not millions, of qubits, this unitary computing measure of a quantum computer. So companies absolutely implementing things like quantum encryption, quantum sensing, quantum communication. They're really getting ready for the quantum computing era by learning and building and deploying and testing. And that's going to accelerate more and more.
And which sectors, Andre, do you see the companies who are most active in investing in quantum? Which sectors are these? Finance, energy, where?
Yeah, we all have slides in our pitch decks of the different industries that will be affected first and affected most. Many talk about optimization problems, factorization problems, which you find in the traveling salesman problems, so logistics. How many trucks does FedEx put on the road, and what is the optimal route to deliver those packages in an optimal and most cost-efficient way? New compounds, new materials, and here we look at medicine. Obviously, in the context of the current COVID-19 pandemic, there was a question about quantum computer could help solve this and find a vaccine, which in theory it absolutely could. We're just not there yet, and there are a lot of other issues surrounding that. Finance is a big application to build financial portfolios, high-frequency trading, and anything that touches data in general, quantum computing for machine learning, artificial intelligence, and so forth.
Okay, that's really interesting. So I'd like now to throw questions to the panel. I'm going to victimize one individual to kick off with an answer to the question, but other people feel free to come in to add to it. The big question on everybody's mind at the moment, of course, is COVID-19 and how the world's dealing with the challenges that it faces. It's an open question, and Andre kind of touched on it in his last answer, but I guess I'd like to ask, I'll start with Tony. How is COVID-19 affecting the way that quantum could develop and should develop?
Yeah, I guess I would break that maybe into two parts. One is a little bit what Andrea was talking about, which is the promise of quantum computing. So the promise of quantum computing absolutely has this ability to look at a natural model and disentangle it in a way that a classical computer cannot. And so being able to think about finding binding energies for a molecule and how that would affect kind of the human system, these are things that are on the horizon that you can tackle with this future quantum computer. So are we there today? We are not. What you can do is shrink down that problem size to a smaller molecule that you can test out. And the reason that's important is because we are going to cross a threshold, and even Google's announcement around quantum supremacy, it had a very particular point to it, which is you will cross this boundary where there's no way to fact check. There's no way to prove through a different classical method that was the right answer. And so taking this time to show that, yes, when you evolve these systems, you evolve the capability of a quantum computer, you are consistently getting that correct answer, is to some extent building up the trust that you're going to need for when you actually cross that boundary layer and you can start tackling development of new molecules or finding new ways to fight a disease like COVID-19.
How would you answer that, Anthony?
I think that Tony gave a good answer. Let me just maybe follow up on one or two things. I think COVID reminds us, I think, that there are many hard problems left in the world. problems where traditional computing, traditional approaches just have fallen short for a variety of reasons. So I think it provides one of those beacons of need for quantum computing. At the same time, it certainly does pose some practical challenges. Trying to empower a community, trying to engage a community, at the organizational level, at the individual level, it is harder. It is harder now, but I think that this is a temporary phase that'll pass.
Okay, Denise, any views on this?
Well, I'd like to talk about it from a different perspective, and that is one of a startup company or a lot of emerging quantum companies trying to do business in the midst of this crisis or pandemic. And it's, I think we all read in the newspaper that there's been a lot of difficulty in fundraising, but I'm really enthusiastic to see that there are still quite a number of quantum computing companies that are fundraising in this environment. I know at Cambridge Quantum, we've had tremendous business, and our business has not stalled at all due to the environment. So I would say that people notice that this technology really has legs and is keeping on moving. And so even though we're an emerging technology, I feel that the market and the industry understands that this is worth investing and worth moving forward even in this crisis time. Andre, I don't know if you want to add to that or?
Yeah, looking at the industry from the outside and analyzing, we have this famous term of the quantum winter that has been going around for a couple of years. At what point there might be a shakeout in the industry because of too much hype and results just not following suit. And this pandemic and crisis really has accelerated that. And I think, maybe surprisingly, a lot of companies have done tremendously well. Just yesterday, I spoke with the CEO of a Fortune 500 company that so far has looked at individual use cases in their quantum computing program that they have been trialing for a while now. His question was, is there a bigger picture? Is there something more core, more central to our activity, which is an industrial activity that we can be doing with quantum computing? And there's an increasing number of hardware, cloud, software, but also consulting, analysts, and media offerings and services out there to support all of this. So it is really progressing really fast. And Ryan in the audience asking if those systems will be robust or require future requirements. They are just developing extremely rapidly, notably thanks to IBM and Honeywell, that really make this available in the cloud and allow everybody else to learn and to build, and that is fantastic.
Okay, that's great to hear. And are the levels of skills coming on stream as well? Young graduates, people with postgraduates in the areas that we need in quantum to really push this along. Are we seeing this increasing at a really exciting rate, or are any of you worried about it? Maybe Denise wants to answer it first.
Yeah, so let me take this. I'm really enthusiastic. There are an increasing number of programs teaching quantum even at the high school level, for example, through University of Harrisburg. There's a very robust meetup ecosystem. So there's a lot of education going on and a lot of interest in quantum. And there's more and more resources available every day. And this is in addition to, I'll hand it over to Anthony. I think that's my job right now, to hand things to Anthony to talk about what the Q Network is doing as around education.
Anthony.
Well, thank you, Denise. Yeah, let me talk just a bit about that. First, I'll say that, the long term, because of the initiatives that Denise mentioned and many other things, I'm very optimistic. I think that we will meet the talent challenge, the skills challenge on quantum. In the near term, there is definitely a skills challenge. Just finding people that can contribute into the various dimensions that are needed to develop quantum technologies is difficult at times. So to address that, through the IBM Q Network, we have a number of initiatives. We partner very closely with universities in a growing number to help develop curriculum that is a good match to what we think quantum technology development needs in the near future. We also have a very broad set of initiatives to produce open source and openly accessible content, including an open source textbook, video content, and many other pieces that can be used broadly, in universities, in industry, and other places. So we think it's very, very important. Obviously, we think there's a near-term challenge. Long-term, I think we'll be in very good shape because of a lot of the work that many people are doing, and I would count IBM as part of that.
Sure, good. And Tony, how are you finding the skills issue?
Yeah, I try to put myself into the shoes of maybe the person asking the question, saying, do I need to be a quantum physicist to have a job in quantum computing right now? It takes some of those, but what we have found, and I think what has made us successful, is you need to have a very multidisciplinary group of people who are focused on this. It takes quantum physicists, it takes quantum theorists, and then it takes electrical engineers and mechanical engineers and computer scientists, and it takes the folks that are helping us in our business development, and it takes our laws and contracts folks, because it really is a broad, exceptional kind of skill set that you need to be able to develop over time to make this scalable. And I mean scalable both in terms of getting bigger and more powerful quantum computers, but also so that the team itself is acting at scale. And what we found is that, yes, you may be a scientist where that's what you knew you were going to do for the last 10 years was quantum computing. But you also may be a software programmer that does Python coding that you kind of never heard about quantum computing until yesterday. And we have, and I say we, like the community, we have needs for both of those right away, because it's only with that kind of collaborative iteration that we've seen the success continue to rapidly mature.
Interesting. Do you have a perspective on this, Andre?
Tony works for Honeywell. I think everybody knows Honeywell because you have a thermostat on your wall that reads Honeywell. It's a very old and, I mean this in the best sense of the word, conservative company. So if you see somebody like Honeywell getting into this because they actually realize they have the expertise, but also the market to do this, that just shows you that quantum really is here today. As a user and a business, you might not see a financial bottom line impact or a new science fiction product or service just yet. But it is absolutely the time for anyone from starting at the high school level all the way up to professionals to start thinking about quantum. It's a different mindset. It's a little spooky, as Einstein called it. And it is something that is only going to accelerate and really touch every enterprise process that we as consumers interact with. And I think understanding this is really important to anyone, not just PhDs in quantum physics.
Sure. Okay, well, let's look forward to more of those skills coming on stream then, because it sounds like we need them. There's a separate question on my mind, which is about, which I hear people talk about a lot over the last few years, which is artificial intelligence, which could revolutionize the way people do business and also revolutionize the way people in government work. How can quantum be applied for artificial intelligence? Maybe I'll ask Anthony to kick off that answer.
Sure. I think the detailed, accurate response today is we don't fully know yet. What I will say is that in the last couple of years, using the devices we've been able to build, the near-term systems that we have seen interesting signs that quantum, relatively near-term quantum systems can accelerate certain aspects of AI, right, of machine learning training and of inference. That has taken some form in binary classification. There are no proof cases yet that this will definitively speed up or make more efficient or make more accurate this sort of classification, but some very encouraging signs in the last couple of years. Personally, I think that there's a great potential here. If you look at why a quantum computer works or why it offers the promise it does, the quantum device offers a space, essentially a number of variables that scale exponentially with the size of the system or the number of qubits. Now that, combined with the linear nature of quantum mechanics, right, the linear math behind it, actually makes what is the building, the basis, the potential building blocks of a very interesting way to perform linear math at exponential scale. So that actually is what you need to accelerate machine learning. The devil is certainly still in the details there, though. And so while we have work to do, I remain encouraged.
Okay, and Tony, are you encouraged as well so far?
Yes, absolutely. I think there are a number of areas that have the early stage showing impact, and that is things around big classes, things around optimization, things around machine learning, and chemistry or material science. And within that, again, you almost have to mentally rewind 50 years ago, something like that, 60 years ago, where somebody could compute on a piece of paper faster than the computer right next to them could compute. The tools that we have today, and it's right to think of them as tools, you have to go build up your skill set on. And what's going on is we are using quantum computers that are the capability that exists today on a problem that, as Anthony talked about, the problem itself scales, and it scales exponentially, which means that it lends itself much more to quantum computing than it would ever to classical computing. And you can take that problem and shrink it down and test it out on the systems that exist today, knowing that as you scale that up, you're going to have a larger and larger capability and therefore a larger impact. And so we're seeing that in artificial intelligence applications, in machine learning applications, in quantum chemistry applications, and it really is now both kind of getting the most out of that by let's call it tweaking the system, but also scaling up now the capacity of the quantum computers themselves to be able to tackle those larger problem sets.
And Denise, doesn't Cambridge Quantum Computing have a machine learning practice team?
So we do have a machine learning practice team. And I also wanted to mention that we recently have published some experiments that we've done on quantum NLP. So we're evolving where current NLP is around word recognition, and we're evolving to sentence recognition using quantum computers. And we've published our first set of results that were actually run on an IBM quantum computer. And there's a very exciting stream of research that we have a whole team working on, headed by Bob Cook from Oxford University, where we feel that we can make a huge impact in the future on NLP using quantum computing. So that's an exciting new development that we're all very happy about.
And what's your view on the issue of AI and quantum then, Andre?
I am very intrigued by it. I'm even more intrigued by this idea of data. So kind of a step before machine learning. And we live in a digital data-driven economy. A lot of our companies and businesses run on data infrastructures, data that you need to sort, search, ultimately analyze. So I think there's a future where ultimately quantum computing will allow companies in certain industries and verticals to fundamentally change how they work with their data.
If I could, there's a question from the audience from Edward. Edward asked, with machine learning requiring more and more energy, so if you think about every time you double the size of a supercomputer, you're doubling the energy consumed. There's a lot of energy consumption there. So it certainly will be more green to use a quantum computer, which has much lower energy requirements for any computing solution, including machine learning. So as the technology grows, it certainly, at this point, looks like it's a much greener solution.
I would add, there's as I mentioned at the beginning, this era of classically impractical. when you think about what makes it classically impractical, there are typically 3 dimensions. First is it takes too long to do, so no one's going to wait for that answer. It costs too much to do, so no one's going to pay for that answer. But there's a third one, and it consumes so much power to do that you wouldn't do it. And you don't do it because your entire organization or your company is kind of centered around this idea of sustainability, and it just does not match up. And so absolutely, quantum computing has this promise of being able to do much, much more efficient calculations, again, for a certain class of problems that are these exponential hard problems. And we're certainly already seeing that has a lot of promise.
Sure. I mean, that might answer one of the questions which I had, which was, do you need quantum if you've got a supercomputer? Anthony, yeah.
I was going to just illustrate the point even further. Sure. So if you think about what it takes to double the capability of a high-performance computer, or any computer really that's based on ones and zeros, if you want to double its capability, essentially you need to double its size. You need to double how many bits you have. You need to double, how much data you can ship in and out of it. In a quantum computer, because of the exponential scaling that a number of us have alluded to here on this panel, you can actually double the capability of a quantum computer by adding just 1 qubit. So if you have 100 qubits, you want to double the capability. You can add 1 qubit to 101, and you get twice the size of the space that you can compute with. That is the power of an exponential. That's the promise of quantum computing. What does it take energy-wise to add 1 qubit when you've got a whole bunch already? Almost nothing. So the energy scaling is incredible, along with a number of other potential benefits. It's really a foundation-shifting type of technology in that sense.
Sure. Anybody want to add to that?
Well, my fellow panelists will forgive me the analogy. I use an example between a bicycle and a jet plane sometimes when trying to explain this to a novel audience. You take your bicycle to go to the corner store in the morning and pick up your baguette, right? You wouldn't take a jet plane to go to that same corner store. Obviously, a jet plane is a lot faster than the bicycle. With the jet plane, you can also go to places where the bicycle, no matter how much you improve it, will ever be able to go. So supercomputers, classical computers, have been pushed tremendously, and we've done an amazing job at it. Classical computers, quantum computers are a lot faster, but that is not the point. It is different laws, different dynamics, a different thinking behind it that allows you to do things that classical computers, supercomputers, just aren't good at.
And I think I want to just make the point that I think there's quantum computing and supercomputing are complementary technologies. I think we're still always going to need supercomputers, and we're always going to need quantum computers, but I don't think that quantum computers are going to replace supercomputers. I think I've seen some market research studies where they suggest that, and I think that there are problems that are better suited to a quantum computer, like what we've discussed today, and then that, if you're going to use a Word document or you're going to do something, you need a different type of computer. So I think that these are complementary technologies, not exclusionary technologies.
There's an interesting corollary to that, which is people ask me, so when is a quantum computer going to be small enough to be on my phone? And the answer is, it already is. That is how you can access the quantum computers that exist today, whether it's IBM's or Honeywell's. We've had our theorists literally from their phone sending in jobs to our quantum computers and getting results out. That is how the future of this is going to look, because massive data centers or how people access the internet today, you may not even know that there's a quantum computer that's running your job in the background. You don't care about that. You don't care about how that happened. You just care about the results. And that is very likely to be the way that most consumers and frankly most businesses are consuming quantum computing.
Sure. Okay. Fascinating. Well, we've just got 4 minutes to go. I just want to ask a question from a different perspective, which is about the difficulty of quantum. Why is it? Can you give an idea to the layperson why it's so difficult and why progress has been irregular? Who would like? Maybe Tony would like to start. I can see him nodding.
Yes, it is. I do. One of the things that I get all the time, especially when so there are different underlying foundational technologies to make different kinds of quantum computers, and Anthony will maybe touch on that for what IBM does. For Honeywell, we use something called trapped ion, which is using individual atoms to be able to turn them into our quantum bits, our qubits. And if you hold your hands together like this, you have about a trillion atoms in that space. Imagine having to sort that out and just grab individual ones and be able to physically move them, put them in a space where you can hit them with lasers, move them around again, hit them with more lasers, and all in an attempt to do one thing, which is to find out whether it's light or dark. That is the underlying technology, and it is hard. But I have to say one thing as a person who's leading this within Honeywell, which is I am really glad it is, because once you figure out how to do it, that provides a lot of intellectual property protection.
Anthony, do you want to add to that?
I guess I would just add by saying, quantum is hard for the same reasons that Einstein and Bohr and Heisenberg and the other prominent scientists of the 20th century thought it was hard. It's because it's different. It's a different way of thinking. We're used to thinking in concrete terms. We're used to thinking in computer science in terms of ones and zeros. That's been the paradigm for 70 years or more. Quantum changes all that. Quantum is thinking in terms of these esoteric concepts: superposition, entanglement, interference. These are not the way the world works. It's not the way we're used to thinking. If you can delve into that, though, conceptually, and in the mathematics behind it, then you can really uncover something that is truly groundbreaking and truly, truly promising.
Sure, there's a few ifs there, but I'm encouraged by that.
I can elaborate, but lots to say there, indeed.
Sure, Andre.
Yeah, and just by the way, there's a question from Diego in the audience for learning resources. IBM is a great starting place for that. Just Google IBM Quantum, IBM Q Network. And to what Tony and Anthony are saying, on the product and technology side, all of that is incredibly hard. The business side is also incredibly hard. What is a use case? How do you define it? What kind of team do you need around it? What kind of skills? What is your revenue model around it? I need to figure out the software. I'll call Denise. Denise has software, but it still needs a lot of work, even so it's the leading software out there. So there's a lot, even on the business side, that we just don't know yet. How does an investor do due diligence on a quantum tech startup? Just a lot of new questions that we need to find answers to.
Yeah. Do you want to comment on that, Denise? It's a good point.
Well, I think equally hard to the hardware development is developing effective software to solve real-world problems. And that's where Cambridge Quantum Computing specializes in taking the real-world problems and translating them quantumly, as we say, and developing a solution. So it's a very promising and very tough thing to do, but that's where we specialize.
Great. Okay. Well, I think we're almost out of time. Is anybody, I'm not seeing the questions from people who are watching this. Has anybody seen a question that they'd like to answer before we leave?
I think we're out of questions and time.
I think we're out, yeah.
Okay.
Tabitha.
So the good news is you'll be heading over to the Q&A room, which is where you'll see the questions that people have asked you.
I can't see the questions, Tabitha. Sorry, I don't know what I'm...
You're going to be transported like Spock into a new room, and that's where you'll see them. You won't even need to move. So what I'll actually do now, though, is I will close this stage, which is where we're streaming, obviously, live to YouTube. And those of you who are in the CogX app, you'll be able to head over to the Q&A breakout where you can ask that illustrious panel your questions. But for everybody else, good night and